You're listening to Electrician Live with your host, Paul Abernathy. What up, everybody? Welcome to the stream. Our normal during the week. Usually it's Wednesday night, but I'm messing around with some software, and I have a special guest who is on the line. That is also an aficionado. He's Mike Holt's expert on exam prep. And I'm sorry, I should have said that. We are live streaming from Casa de Abernathy. And so most of you know, and I'm looking at the extension to see the dashboard. So we're going to talk exam prep tonight like we always do for those that happen to funnel in, and we'll get some thoughts about exam prep and things to prepare for. You always familiar with my normal exam prep. I should say that this is also streaming for anybody that does watch over on the YouTube channel. So you can go watch over on the youtube.com/master the NEC. So there we go. Okay, so now I am over on my stream. Vince, are you there?
I am here, sir.
All right. Welcome to the stream. We have some viewers on that typically come to our exam prep evening that we have. You know, usually it's on Wednesday evenings, but tonight I was testing out some software, so I figured let's do some exam prep tonight, or at least look at some exam questions and things like that. And I will share that all with everybody, and hopefully share it with you too, Vince, so you can see what it looks like as we look at the exam prep. Also, for those that will stream in that aren't familiar with it, we have our Fast Tracks program, which is what we do pretty much all of my exam prep based on. In the 2020 edition of the Fast Tracks is going to release on May 25th, for those that are interested in that. And we have got the 2017 edition that is out right now. So those that are, obviously we have well over 300 people in that current program that are working in this first quarter of 2020. It's January, February, March, and April. And we've started into the May edition for whoever signs in for that is the May edition of that. Okay. So without further ado, let's see if I can't get some of this stuff up on the screen. As you can see, was messing with some Zoom stuff here, obviously. And let's see if I can get into program. Of course, it isn't up, because I didn't know that I would jump into it so quick, but I will. And I'll share it with you, Vince, as I get this going. Okay. Get it quick. And let's go into some mega pack questions. Just go down to this one right here. All right. Let's share my screen with you. All right, Vince, I don't know if you can see the screen.
Yeah, I got it. Mm-hmm.
Okay. You able to see it and everything? The questions okay?
Yeah, it looks fine.
Okay, good deal. All right, so those that are over on the stream, we've got some exam questions like we always do. Okay, they're starting to file in. How you doing, Sandra? 12 Mandingos, thanks for coming. Paul, thanks for coming. And let's see here. Let's see here. Vince. Oh, bear with me, guys, while I'm using Vince as my guinea pig. So trying to get this thing captured. So hold on for 1 second. Hey, y'all that can see the actual screen, I'm not sharing the screen with y'all yet. So let me go on and share that screen with you all. Again, I'm winging it tonight. Let's see here. Okay. Let's go to the browser. Okay. All right. For those that can see it on the browser, I'll have to figure out. I just figured out that I'm probably going to have to use Skype for my integration in the future. So that's something that I learned pretty quickly just now, that Zoom is not going to be the choice medium for me to do this. It lacks great integration. So anyway, anybody see the questions on the screen? Vince, can you see the questions on the screen?
Yeah.
Okay. So as I tell people with the exam prep now, Vince is experienced with exam prep as well. He works with Siemens. Vince, what exactly do you do with Siemens?
I kind of have a two-part role. One is I'm part of the Siemens Codes and Standards team. So there's 6 of us in the electrical product group who deal with codes and standards with most of the products that probably most of your listeners and you and I know. Panel boards, load centered, switchboard, switchgear, transformers, circuit breakers, electric vehicles, most of the equipment that gets installed in buildings on a day in and day out basis. So that's a big part of what I do with Siemens. Also sit on some NEC panels, co-making panels, and some other NFPA technical committees. The other part of my role with Siemens is to support the electrical inspector community, again, from a codes and standards standpoint. And I do a lot of that through the International Association of Electrical Inspectors and supporting their meetings, whether it's at a local division or a broader state level or even a section level. So I get to travel across the country, not recently, unfortunately, but supporting IAI events and interacting with the AHJs and installers too, because a big part of the membership of IAI is the installer contractor community also. It's not just authorities having jurisdiction.
Okay. Cool. Well, there you go. And I think Vince is going to, once we get the video thing, we're going to be doing some stuff together in the future as well. So excited about that. And so the question that we have on the screen that students will see here, and again, we kind of talk about what I like to do is dissecting for the students. So again, the students and those that are listening, I'm seeing the chats and see the conversation and everything. So when I look at a question like this for an exam prep, I mean, obviously, some of the quick tips that we always give you, unless you're used to coming here before, is we're dealing with usually when you're going through an exam prep stage, you've got where you need some kind of structured plan. Of course, the fast tracks is kind of a structured plan, but any study material that you can get that you can utilize, it's going to give you exam questions. And don't worry whether or not you get the question right or the question wrong when you're going through the study material. Just make sure that when you get it wrong, that you actually use the answer to look through the question and see where are the root terms in the question, especially if you lack maybe some code knowledge or able to pick out certain things in the question. It allows you to dissect it by looking at the answer. So it doesn't matter whether you get it wrong. And there's always some crap questions out there that you'll get into that even after you look at it, you'll still shake your head and you won't understand it. And that's okay, because you got to keep in mind who they're written by or who writes them. So all those things have to be taken into consideration. So So in this question here, it says a metal underground water pipe may serve as a grounding electrode where it is in direct contact with the earth for at least blank feet or more. Now, if I was preparing for an exam, as you said, when you go in and you take your exam, you're going to have a certain number of questions that you're just going to know, and you're going to get it right off the bat. You're going to know it. You're going to understand it. It's one of those things where you're going to be able to know the answer, and you don't have to spend any time looking it up. So this is one of those that you probably should know if you're in dealing in 250 and understanding 250.52 and the different types of electrodes that you're dealing with. So, however, if I was going to look this one up, then I would be looking up, definitely going to be in 250, and you can use, like we talk about, the browsing the bolds in order to find, or you can go to the back of the book and look under grounding electrodes in the index. We'll define this as well. Let's see if we have any students with any. Okay. Hey, Nick, how are you? Thanks for coming. Hey, Christopher, thanks for coming. So what do you think, guys? What do you think the answer is here? We got the chat going. We have quite a few viewers in the room. So what do you think the answer? Again, like always, A, B, C, or D, and where might you look up the answer? And I will get the code book out and ready, and we'll go look it up as well. In case we need to look it up. Don't think we need to look this one up. Okay, I see Chris Hawk says 6 feet. Junior says C, which is 12 feet. Christopher Miller says A, 8 feet. Okay. No. 12 Mandingos is actually correct. Now, what's important is we're dealing with the metal underground water pipe. So, again, I kind of gave the code references a little while ago. And we're not talking about a ground rod, 8-foot ground rod. We're not talking about anything that gives you, sizing wise or feet wise. If it's a concrete encased electrode, it has to be 20 feet of rebar or 4 gauge copper. So of our sizing, this one you would know would be a number 10. Or 10 feet, I should say, not number 10. 10 feet or more. And if we were to look into the code book, and here's the code, and again, I don't know that, Vince, you don't see the code book, do you?
No, I still see the question.
Okay, still see the question. That's what I want to make sure what. I'm still sure which. Bear with me. Here's I'm not sure how that's working for the Zoom. That's quite interesting. Because I guess it shares the whole thing. But for those that are in the code or that are in the that are watching on the stream, now Vince, the one way to do this too also would be to go and watch it on the YouTube channel, and then you put the audio on mute. But again, you know how to find all this. So for the students that are watching, one of the ways I would go would be here and go to the NEC, and then I would go down to grounding electrodes, see if there was some kind of reference in there for grounding electrodes. And one of the ways that was, now remember, going through the code book, guys, back and forth, you always want during the first couple weeks of your exam prep that you actually do go back and forth and start looking and trying to pull out root terms that are actually in the back of the book. Okay, so you want to look and see it. Now, of course, by now, you should probably know where we're working out of in 250.52 by now for this answer. But for those that are on the screen that are watching, events that seem awkward to you because I'm actually scrolling for them.
I'm heading to Facebook, and I'm going to see if I can pull you up there.
Yeah, usually it'll see the stream. It could be a delay, but all right. So, and I'm looking in it. So in this case, one of the ways would be if you had your code book, you could do that. Now, so you have electrodes. So it's under electrodes, grounding. And of course, in this case, we're talking about a water pipe ground. So you've got metal water pipe. And then, of course, you've got a bunch of references here, guys. You would actually write those down on your sticky note or your little scratch paper at your exam. And you would write it because you don't want to have to come back and keep going back and forth. Now, as you get more familiar, you'll realize that 250.30 is dealing with separately derived systems. And then you'll see 250.52, and you'll realize that that's talking about the actual electrode itself being utilized as such. And then, of course, 250.68 has to do with how you tie multiple electrodes together, allowance. So in this case, 250.52a is where we would be. And I would go 52A. And here it is, a metal underground water pipe in direct contact with the earth for 10 feet or more. Okay. So for those that said that it was 6 feet, you can't use a keyword index in most states, Chris. You might be able to, they might allow you the Tom Henry one in some states, but most states they're not. So in this case, the answer would be 10 feet, 252, like 12 mandingos. Got it there. So let's go on and answer that question. 10 feet. And there we go. 250.52A1. And that is the answer for that. Okay. All right. Now let's continue on to the next one. All right, guys. For those that are watching on the stream, exam prep, hopefully you got your code books. Okay, what is it, Junior? Oh, you've been in the trade 10 years and you failed times. Don't get frustrated, Junior. Only thing I can think is you need some structured training. If you've done it 4 times and you haven't passed it by now, it means that you need to do something structured. And again, I am going to recommend the Fast Tracks program. Obviously, it's our program, but it's geared towards structure. Vince, you got any recommendations? That, when they take it 4 times and are having trouble passing the exam. I think you recently taken some exams, so you think if somebody's been doing something in your trade for 10 years, do you think it's mental or just, some people just don't test well, right?
Yeah, that's true. Especially if you haven't sat for a structured test in a while, or you haven't been inside the books for a while, it does become it's intimidating to an extent, and it's nerve-wracking for a lot of people. So after 4 times, I agree. It's not time to give up. It's not time to decide on a different career. It's maybe time to just change your study pattern, or try a little different of a way to attack the questions.
Yeah,
But
I like to think that it's I can tell you that with the Fast Tracks, so far the success rate of those that go through that program are 100%. So it's obviously a lot of information. It's an overwhelming amount of info. But you get out of it what you put into it. So I mean, again, these are questions here that are kind of the online. What you see is our program online, and what you're seeing is example of questions. And again, there's timed question tests, and there's competency reviews, and just there's videos and interaction and all that stuff. That's what you're going to need. It's 2 weeks. Yeah, see Junior, that's the problem that I have. And Vince, I don't know if you can see comments now if you're on the stream. Junior says he's taking the weekend 2-day crash courses through ABC and still fail. I keep getting the low 60. See, I'm not a believer in these crash course things, man. I believe that they try to teach you shortcuts. They try to teach you to put too many tabs on your book, and you get you get brain freeze, you get locked up. And then if you try to cram everything in a weekend and pay outrageous prices for cramming on a weekend, only to realize that now you start getting so much information, you start second guessing yourself, or you start questioning the information. So I'm just not big on these crash courses, man. I just don't believe them in the, you're going to pay $6,000-$8,000 to go in there for 2 days and think you're going to walk out there and be able to ace an exam because somebody tells you, here's a shortcut, here's a shortcut. There is no shortcuts. The Fast Tracks program takes you about 90 days to get it really good. You can take longer if you want, but that's about what it takes to be successful in the course. And there's really no way or reason that you should fail an exam if you go through some kind of structured training. I would assume, and again, I can't speak for these 2-day crash courses that you're talking about, but my experience with them is they just don't, they're not a benefit. I just don't find them very beneficial at all. So, anywho, so what do we got here? So again, Junior, I'm going to recommend the Fast Tracks program. Jay's in the program. Talk with Jay or have a conversation on a sidebar with Jay. He'll tell you about the program. He'll tell you all about it, everything in and out of it. Nick, 50. Oh, we got to look back at the question. Hopefully that answered, Junior, but no, don't give up. Never give up. Okay. Next, the question is, when calculating the demand load for a one-family dwelling, what total minimum VA must be included in the calculation for the required small appliance and laundry circuit loads? Okay. So interesting question here because it's actually giving you the small appliance and laundry circuit loads. So again, this is one of those ones where doubt it will be on an exam like this, but one of the things to look at it is what are they asking you for? Because it's so easy on this question to say 1,500 VA because that's what you would get for the small appliances, and you got a minimum of 2, and then the laundry circuit would be 1,500. But the way that this reads, it's saying what calculating the demand load for a one-family dwelling, the total VA, the total minimum VA must be included in the calculation for the required small appliance and laundry circuit loads. So, I mean, I can get this one wrong. You don't never know how the person that wrote the question's what they're trying to achieve. But what I can tell you is that I'm going to expect to see 1,500 VA for at least the 2 small appliances. So that's 3,000 plus the 1,500 for the laundry. So that's 4,500. That's a plausible answer here. Okay. So, and obviously every one of them is plausible. Now, if the question comes back 1,500, then again, don't fret. That's what it is for each one of the circuits. But the way the question's worded, I'm thinking they want the total load. Since they're talking about demands, they're telling me I want the whole value. So there you go, Elwood. Thanks. All right, so I'm gonna do 4,500. Boom, there you go. And that's exactly what the question was trying to allude to, is the required 2 small appliance and 1 laundry. Keeping in mind that you could get a question where it just wants to know what the VA is for any given one of them, that type of thing. But that was the answer for this exam question. So, next question. Underwater luminaires installed in swimming pools are required to have GFCI protection if they are operating at a voltage greater than blank. A is the low voltage contact limit. B is 50 volts. C is 120 volts. And D is 15 volts. Okay, so if I was dissecting this question, obviously it's swimming pools. Obviously it's 680. And there's a portion in 680 that deals specifically with underwater luminaires. So probably, since this is generally also, little tips for people, 680 is broken into different parts. And so if you know, for example, that part 4 is pools and spas, and you know that it's before that, If you didn't want to go looking up in the back of the book, of course, you can look up underwater luminaires or swim under swimming pools. Either of those would be triggers. Then you should be able to find pretty quickly where you need to be inside of 680. But again, for those that do the scanning technique that we talked about last week, I could go right to part 4, pools and spas, knowing this has nothing to do with that, and then work my way backwards looking at the bowls until I see something that deals with underwater luminaires. But for me, I'm probably going to, and as you all know, I'm probably going to say, and it's not the end to meet all using the index, obviously, but it is a good reference to be able to go back into the index and go under here. You would go, I'll just go and say it's swimming pools and see what we get under swimming pools. So for those that are watching on the stream, I'm going to go. And incidentally, Vince, we're going to do something at some point on swimming pools, aren't we?
Yeah, that's the plan. We're going to take a deep dive into 680 and cover a good portion of it.
There you go. Now, for those that didn't know, Vince serves or will be serving on code making panel 17 with, and I will be, at least that's the plan, unless they remove me. It's always possible. I think it's all set now, so I will be on the panel as well, and so will Vince. So there goes the neighborhood, I guess I should say. All right, so as you can see here, I'm under swimming pools, and then I'm looking at luminaires. And again, like we always say when we're doing it, in the code and we're using the index, and again, it's not always the answer, but I remember that on my little scratch pad, I'm going to write down all of the sections. Since we already know it's 680, I'm going to write down on my little scratch pad .22, .23, and .24. Now, I don't necessarily have to write the whole thing out because once I get there, I start scanning for those keywords that I want. But I'm going to go to .22 of 680 and see if that's going to give me what I need. And so again, when you're using your book when you're taking the exam, again, you can just go to those .22 and let's see here. Okay. All right. So you look and see, and so obviously it's much quicker than I do with that. Would never, ever expect to take an exam with a PDF because I would never finish. There's no way. It's just crazy. Okay. So again, that's dealing with your bolding, see? So this is receptacles. And then I'm going down and I'm getting underwater luminaires. So I happen to be here at 680.23 and GFCI Protection. Okay, that's my dog. All right, so GFCI Protection for personnel shall be installed in the branch circuits applying luminaires operating at a voltage greater than the low voltage contact limit. All right, so looks like that's the answer. Or let's see what we got from, we go back to the question and we'll bring up some answers here. What do we got? 50 volts. I got some people 50. Joe. Thanks for coming, Joe. Wow, we got a lot of people in here tonight. Let's see here. Okay. All right. So it looks to me like the question said low contact limit. And that was 680.23 A3. Okay. Well, let's see here. How many of you got that? Or did you even try? Hey, well, Mandingo, did you answer it after I posted the answer? Is there that much of a delay in it? So, okay. All right. Yeah, let's see. Smiley face. I got you. All right. So let's do another question. All right. Any one cord and plug connected portable appliance connected to a 120 volt, 20 amp rated branch circuit shall have a maximum rating of blank amperes. Okay. So think about this one, folks. We're talking about a branch circuit. That immediately when I'm looking at this question and I'm going to think that this is something 210 driven. So I've already kind of know that. Cord and plug connected and portable appliance, all of that's, very in it. So one thing about this one is that somebody might say, well, would this be under 422 or would this be under for cord and plug connected portable appliance? Or would this be under 210? Well, since we're talking about the rating of the branch circuit, in my mind, if I was preparing for an exam, I would probably say that this is an example where I would be in 210. Now, my mind's thinking 210.23 area, 22 area, somewhere right there. But let's look and see what we can come up with this if we use the index. If you had no idea and you want to use the index, let's kind of do that real quick, because I know that that's y'all have fed the feedback that I've gotten is y'all like when I do that. So I'm going to look now. While I'm here, I'm already in A's, right? So I'm going to look and see if anything under appliances, just because I'm here. So here's appliance. All right. So, here's branch circuit. It says see branch circuit appliances. It's not far away since I'm already in, I'm already in A, I'm already next to B. So let's just go to branch circuit and see what we've got. So here's branch circuit and appliances. Okay. 210.23, which is where I was thinking about earlier, right? So that's where I feel like I'm in a good place. So that would have gotten me there. But you notice how it says 422 part 2 as well. So this could be interesting. But anyway, you have two references that if you're doing like we always talk about, usually you have your little dry erase, or they give you a dry erase. I don't know what they give you up there, Vince, up in where you took the last one. Was it a dry erase pad, or did they give you a scratch paper?
They gave me one piece of scratch paper at a time.
One at a time.
And when I filled it up and I ran out of the room, I had to go ask the proctor for a second piece and hand them my first piece. I couldn't keep the first piece.
I'm afraid you might be making notes that you want to take back. Okay. All right. Heaven forbid we take any kind of note out of a test center. All right. So typically what I do here, folks, is always, I tell you, I will jot down, and I'm looking for my little scratch paper and I can't find any. So there we go. So I've got, remember, I used to go 210.23 and then 422 part 2. Just as my references on where I'm going to be in here. So I'm going to go to 210.23. And if an exam, remember, also, folks, I tell you all up front, as I've always told you, take your time when it comes to exam prep. The speed will come. Don't try to be so worried about your time and everything starting out. Okay, you just need to take the time. Okay, it's just simple. Now you see that we have this on the board. So while you've got it here, we're going to go back to the question for you. So again, it's a cord and plug connected portable appliance connected to 120 volt, 20 ampere branch circuit. Shall have a maximum rating of blank amperes. Okay. So, you with me? Okay, let's go back to the NEC. So the maximum core connected, so the circuit is 20 amp. So this says that the maximum load is 16 right here. And of course, we can also go up here and look here. See, here's a 20 amp circuits, and here's cord plug connected equipment, not fastened in place. The rating of any one cord and plug connected utilization equipment not fastened in place shall not exceed 80% of the branch circuit rating. So last time I checked, 20 times 80% is 16. So again, here's your cord and plug connected. That gives you the pull from it. You saw that, you get it. Down here, you see references in 210.21b2. And that says for 20 amp, it is 16. And that is that application. So again, something seems to line up. Now for craps and giggles, we will go to 422 because, again, this is supposed to be helping you all be able to navigate. And at least that's what the emails that I get about it. And so here, we want to go to part 2. You can figure out right here. So your individual circuits, and I hit the bolds. Nothing of that is of benefit to us. Flexible cord, none of that stuff is of benefit to us. None of that stuff is of benefit to us. We're not talking about any of these specific appliances. Okay, so I would go back to the code. Let's see what the questions here, what we got from the people that are in the room. Mandingo says, oh, wait a minute, I got to answer some questions here. Trinidad, what is the low voltage contact limit? In the National Electrical Code, you have a definition. It gives a specific. I'll look that and show you that in just a second because it's 4 different values depending on what you deal with, okay? I go live all the time, Junior. I still have one scheduled for this week, Wednesday night. I'm still going to do it. That one's going to be the voltage drop show, where I'm going to talk to y'all and give you all examples of voltage drop. So we're going to do that. That's still Wednesday. Tonight was kind of an impromptu thing. I'm testing some systems, and my good friend Vince from down in Florida agreed to come on and chime in, although I'm talking all the time. Chime in anytime you want. You know how to shut me up. You can do it. You know how to do it. All right. So it looks like Mandingo says it is, and I'll show you that in a minute, Trinidad, the low voltage contact info. All right. So looks like he says 16. That's what seems to be the answers that we keep coming up with. So let's go on and see it. Correct. 210.23A1. So that's what we did. And of course, to verify that, you guys know I always do this. I'll go back to the code where I was, and we will verify. And let's see here, 210.23A1 right there, and that's where we were. Again, that's the 80%. Just so happens that cord and plug connected loads to a receptacle I happen to know was exactly the same anyway. So again, you could have had 2 ways that you could have got that right. But of course, we're not talking about receptacles. Okay, so there you go. And let's see here. Who got that right? Is that you, Mandingo? Yes. Very good. Where my other guys at tonight? I don't know where everybody else is. Jay, you still in here? Tim not in here tonight? All right. Let's go to the next question. Very good, very good. All right, guys. The service disconnecting means for each individual residential service shall consist of not more than blank switches or circuit breakers. Interesting one here because, well, I won't get into it. Y'all probably seen my code change that I've done about code changes and whatnot, that the 6 disconnect rule is still in effect in the 2020. It just can't be in one cabinet. But oop, crap. Did I give the answer away, Vince?
You did. So they got the bonus there.
That sucks. All right. So somebody tell me where that is in the code. Somebody give me a code reference. I see Elwood. Can't see the question. Oh, well, that sucks because you're right. I didn't give you a question. It doesn't matter. I forgot to hit the button. It doesn't matter because I gave you the answer. I blew it. It's Vince's fault. All right, so sorry about that, Mandingo. Oh, hey Jay, cooking dinner. Man, you are the Martha Stewart of the code world, man. All right, Trey, that's a new name. I haven't seen you in here. 230.71. And your answer is 6. I would assume you're to back that up. So yes, and since I gave that away pretty much, we'll go with it. There you go, 230.70A. Very good. All right, next question, guys. All right, so again, remember when we're doing exam prep, we talk about it. Those that are new, I should say that Wednesday night is will be my normal, where I do a fast tracks demo and then I'd go into code stuff. We're going to do voltage drop. Last week I did dwelling calculations, optional again for you, and answered some questions, I believe. And so we're going to do voltage drop, and I'm going to give you all the formulas that are associated with voltage drop and how to work them back and forth and up and down and whatever you need. That'll help you be able to answer any question you might run into an exam. Interesting enough, sensitive electronic equipment and fire pumps are really the only aspect of the NEC that mandates voltage drop. Everywhere else is a recommendation, but it is required in the energy code. So again, if I had my druthers, I would get the NEC to adopt the voltage drop, but everybody would say that's just me pushing it as a wire and cable guy, so I won't. But I do think it has its place. So anyway, all right, so I've given you all enough time to answer this question. The front edge of a switch box installed in a wall constructed of wood gives it away, shall be blank from the surface of the wall. So how deep can I place the box back into the wall? Well, obviously the reason that we don't want it to be, well, I'm going to give the answer away. Hold on here. What's the questions? Number one, A says set back a maximum of 1/4 inch, flush with or projecting out, set back a maximum of 1/2 inch, set back a maximum of 3/8 inch. Well, the issue with this one here is obviously if I was doing this in an exam, this is one of those ones where you go through that first wave and you just answer everything you know. Okay, you just answer the questions that you know and you keep moving on, because this one you should know. We're not talking about gypsum, non-combustible material. We're talking about wood. So it's got to be, this should be deductive reasoning here. But before I give the answer, I want somebody in our stream to tell me where you would go to find this answer, rather than just give you the answer. So let's see. Well, of course, you know that this is dealing with boxes, right? So we're talking about a switch box, still a device box. Okay. So if I was going to look it up in the code, and I'll just wait until somebody out, because I'm watching the stream, and I'll see if anybody wants to give me an answer. And you've got all kinds of things on here, and then I'll just kind of leave that right there and then see if somebody wants to give me an answer. Okay, Arturo says 1/4 inch. Think about that again, Arturo. We're talking about a combustible material. Good, Elwood. They give me the answer. And I'll go back to the question. And there you go. So you can see the question. So the big deal here is, if combustible material, if it's set back in the wall, there's a potential, if there's an arc, or if there's something at the terminal where this arcing could take place, which typically you'd have something referred to as a series arc. If you had a termination connection issue to a lug or to a screw, then your arcing could take place. If it was set back in the wall and it's got combustible material, then it could cause an arc to get out and cause a pyrolization of the actual wall material. So you don't want it to set back at all. You want it to be either flush, or you want it to project out from the surface. And again, it's absolutely right. 314.20 is going to be your code reference. But again, in this one, I'm thinking it's dealing with boxes, because that's the question. Okay, so one of our root dissecting of the question is the front edge of a switch box installed in a wall construction of wood shall be blank from the surface of the wall. Switch box, boxes, 314. That's where I want to be. Now, of course, you can use two methods. You can go to the index, or you can go to 314, and you can bold scan it. In fact, for those that have been, as we followed last week with our bold scanning technique, you'll see that this is pretty early on in 314. Okay. So I could have probably gotten by simply hitting the bolds, and you'll see that as you hit the bolds, you'll see this flush mounted installations. And of course, if you're looking for wood, wood is there right there. But again, that would have been one way to do it. Now, obviously, the other way would be back in the index. And if we were in the index, we can look at, I guess we can go to boxes and see what we've got under boxes. As you hear me tell you all the time, that there's the box using the index is good. It's not the holy grail. Okay, it's not the holy grail. You're not going to get everything answered by going to the index, but it's a pretty good. If you don't, it gets you in the right location. At least it cuts down some of your time in hunting around. Okay, so I've already seen a reference that was good for me, but I'm looking in seeing what would stick out under boxes. That would be to get you area. Well, if I was doing it, I probably would here is look at flush mount at 314.19, even though that's not exactly the right code reference. Again, you're not going to have everyone in here, but that would have gotten me to a point where I can do my bold scanning that we talk about, because again, the index is kind of limited. Or I could have used here minimum depth 314.24. It would have got me in the roundabout area. Then I could start looking for those key terms, those key bold things that stick out. But that's kind of, here's, 314.20 concealed work, but I don't know that would have helped me any, to be honest with you. I don't think that would have pulled in anything. Okay. So that is ways that you could have found it or got you at least close enough. But this is one of those ones where, again, as I tell people all the time, you're studying. These are things that if, for example, if you're in the fast tracks, and this is why the fast tracks is so beneficial, because you go over every little piece. And this is one of those questions that you're going to answer right away on the exam, and you just bought yourself 2 minutes of a banked time for a more harder question than this. So what do you think, Vince? A, B, C, or D? Is it set back a 1/4 inch, flush with or projecting out, set back a 1/2, or set back 3/8 inch if it's a wood wall?
Like flush with or projecting out.
Absolutely. So we're going to do that. And there you go, 314.20. All right, next question. When doing box fill calculations, and for those that didn't see it, I sent out some graphics that I just made for those that are interested in the 2020 about the box fill change when it comes to equipment grounding conductors. And some of the comments I got is like, wow, this code making panel got nothing better to do, or it's like, boy, they're reaching. And I'm like, I just remind you that most of the time the code making panel members don't have time to sit there and create stuff like this. It comes from public inputs. People submit it and then they will look at it. And if it has plausibility to it and it's substantiated, then it'll make it in the code. So those that didn't like it, it used to be we could have any number of equipment grounding conductors in a box, right? And we didn't have to account for them. Only 4 of them now have to be accounted for the full value. And then you have to get into what's called a 1/4 volume for each additional conductor over 4, equipment ground over 4, or equipment bonding jumpers over 4. In the past, you could have had 50 of them in there and only count as 1 conductor. Do they not take up space? Absolutely. So they have to be accounted for. I'm neither here nor there about the rule. What's your thought on that, Vince? I'm sure you've seen that code change, and it doesn't add a whole lot, to be honest with you, but it is space.
Yeah, the conductors definitely take up space. And even though that rule was kind of left untouched for many, many code cycles, you just count your largest one. The tweak that they made for the 1/4 volume allowance is very, very minimal. I don't think, again, I agree, Paul, I don't think it's going to change box sizes for the most part, 90 times out of 100. But there will be a couple of instances where you may have to increase the box size slightly for that, but I don't think it's going to have a big impact.
Yeah, I could see a 4-gang or you know, where you're loading it up, a 3-gang where you're loading it up and you're just close enough, and this puts you right over. And then what do? You look at the inspector and go, "Come on, man, give me a quarter. Come on, give me a little, you know, give me a little volume." But the other thing was that since we have dividers that go in boxes and they take up space and they have to be accounted for, it just makes sense that somehow we come up with a way to account for additional conductors. I just don't know that that 1/4 of an inch per conductor is going to make that big a difference, but maybe we'll see. You're right. All right, guys. So when doing the box fill, a luminaire stud in the ceiling mounted outlet box is an equivalent to blank conductors based on the largest conductor in the box. Kind of like what we were talking about. For those that don't know what a luminaire stud is, it's actually not used that much anymore, but it's the center supporting stud that goes in the middle of a luminaire that typically you would have a rod connected to supports additional weight. And it sometimes, if not all times, also has what's called a hickey that's associated with it as well. Okay, it's not what you're getting in high school. This is literally a fitting or an attachment. Okay, and it's utilized and it takes up volume in the box, so it has to be accounted for. So let's see here. What do we got? We got question. Oh, the answer states is 1. Okay, 314.16b3. Tim's giving us the reference. And okay, so we've got a B3 and we've got a B2. Which one is right? Okay, well, we're gonna have to go to look now because I got a discrepancy in the values. All right, so we're gonna go to 314.16, so we know we're there for dealing with box fill. And really way too far. Kind of got ahead of me. Got carried away there. All right, so here's your clamps. And there's your supporting fittings. And there is your hickeys. And there's your luminaire studs. And they count, again, for the largest conductor, but they count as a single volume allowance. So for the largest conductor. So if they were all 12 gauge, it would be a 2.25 application cubic inch volume allowance for that luminaire stud. Okay, so let's see here. I know we got somebody. So it's actually B3, not B2. Who gave me the answer here? B3. Mandingos and Tim got it right. Chris, you were there. You just saw, the one letter off or one number off. That was it. No biggie. Okay. Good deal. All right. Good. Very good. So let's go back to the code. All right. What is going on with my technical difficulties with my program, folks? It looks like it is stalled up. Isn't that interesting? Considering that this is using my really fast computer, and it looks like it stalled up on the stream. There we go. Oh, it must have been. There we go. Okay. We're all back now. I don't know what was going on with that. I forgot that also I have to tell you I have actually 2 computers running at the same time. So, all right. So, looks like everybody answered D, 1. Very good. So, let's answer 1. Hey, William. Saw you coming in there. There you go. 314.16b3. You still there, Vince? I didn't lose you, did I?
I'm here. And I like this question. You know why? Because it mentioned box fill. And there's really only one place to go for box fill.
Yeah.
See, and that's 314, Article 314 for boxes and pull boxes. So, it should help get from a test taking perspective, get people to the right spot pretty quickly.
Yeah, and as you get further into it, you'll realize that dot 16 is the mother of box fills. So whether or not you're going to the table for metal boxes and pulling straight from the table, or if you're need to do the cubic inch fill and you've got that table, all of it's at dot 16, so it all keeps you right there, and you just kind of get used to it. All right, next question. A branch circuit supplying more than one electric baseboard heater in a residential occupancy shall be rated a maximum of blank amperes. Okay, so it's a branch circuit, and we're dealing with more than one electric baseboard heating in a residential. It shall have a maximum of blank amperes, 30, 50, 15, or 20. So again, not sure whether or not this is a very well-worded question, but we know that it's talking about a branch circuit and it's talking about electric baseboard heat in a residential occupancy. So what's the maximum of the blank amperes? And let's see what we get from the students. And okay, Tim has given us a reference. All right, Tim, we're going to look at you. We're going to look at your reference as well. See what else anybody says. All right, let's do that real quick. Well, let's look it up, Tim, real quick before we answer, and everybody else kind of, you see your options here as you're looking through it. Tim says go to 424.3a. Okay, so we're going to go to 424.3a and see if that is anything to do with it. Then I will come back. And okay, so here is, I believe that's the reference you're making, Tim. Let me check. 3A. Okay, getting a bunch of different answers coming in now. Okay, so individual branch circuit shall be permitted to supply any VA or wattage rating of fixed electrical space heating equipment for which they are rated. Branch circuits supplying 2 or more outlets for fixed electrical space heating equipment shall be rated not over 30 amperes. So not over 30 amperes. In other than dwelling units, fixed infrared, blah, blah, blah. That doesn't do it. That part didn't matter. So we'll do the 30. So I can see where Tim's getting his 30. Okay. Let's go back to the question. See what else we've got. Okay, Mandingo seems to come up with it. Trevor's got 20. All right. So let's go with this one first with the 30. And there you go. That's why I didn't need to question it. That's why we went and looked it up, because you are absolutely right. 424.3a. Okay. Now on this one here, Tim, I noticed that you went to this. Now I would tell, so this is electric baseboard heating. Okay. So where did you utilize to help everybody? And I can tell you where I would have gone, but where did you go, Tim, in order to utilize? Did you go straight to 424 because you saw that it said electric baseboard heat? So you knew that it was probably going to be in 424 because that is fixed electric space heating. And of course, branch circuits are up in the front of 424. So, and I sit on that code panel. That's one actually that Vince is going to be on as well. In 424 and 426 or whatever, and 427 is where I tend to check out on that code panel, and I go to do other things, like visit the zoo or something. Not a big interest to me, but I think if you go again, so this is again, question is asking about, but I'm also the alternate. So Vince, are you the principal or going to be the alternate?
I'm the alternate NEMA rep.
Oh, okay, cool. We can hit the zoo.
I'll go to the zoo with you, yes.
So again, Tim says that he went under electric baseboard heater was the keyword for him. Absolutely. So that is letting you know that that's when 424 is going to kick in, and then you scanned it. Okay, that's a method that a lot of people use, and you just validated that, Tim. That's pretty easy to scan that way. And again, an exam, either you know it, you don't. You can use the index or you scan. Now, interesting. Mandingo said in this one, his route was the branch circuit, so he went to the index. I would assume that's what you mean, Mandingo, and you went to the index. And here you went to the branch circuits. And let's just see what it says for the branch circuit since we're right here anyway. Here's your branch circuits and fixed electric space heating. There you go. 424.3 would have put you right there. Excellent. Couple ways to do it. So that's a method using the index. Index helped you out this time. That's great. The other method was used by Tim, which is the scanning method that we talk about. And that method is very beneficial when you know that, for example, if you know that the article is pretty darn small. Okay, if it's IT, I just go right to it and deal with 645. I deal straight with IT. I wouldn't be trying to look up something in the back. If it depending on the one that you're in, you can get there, and scanning might be your best. And Vince, when we say scanning, I don't know if you do the same thing or teach it. It's basically you go to a certain area and you start scanning the bolds, and you're looking for the terms that are the keywords in the question that you picked out. Branch circuit, electric baseboard heating, things like that. Even as much as the answers. It's looking for 30, 50, 15, and 20 and see if that sticks out in a question. So it's basically like speed reading, right? So that allows you to get in it that way.
Yeah, my technique was always a keyword type technique also, like you're describing, to get close, right? That's what we want to do, get close and see if we could pick off the answer. But definitely a keyword type concept.
Yeah, get you somewhere. Incidentally, is my voice muffled?
No, you sound fine to me.
Okay, because it's been coming out muffled on a couple of recordings lately. So I'm not sure what's going on with that. I got so many things here in the consoles that it's not surprised that I screw something up. Okay, next question. All right, guys. Given an ungrounded service entrance conductors for a one-family residence are size 3/0 AWG THWN copper conductors. Gotta love that copper. A copper grounding electrode conductor attached to a concrete encased steel reinforced bar used as a grounding electrode shall not be smaller than size blank. Okay, one family dwelling, 3/0 THWN copper conductor. A lot of information here. A lot of stuff that's being thrown out to you. Really, it's just smoke and mirrors to ask you, if I have a copper grounding electrode conductor attached to the concrete encased steel reinforcing bars used as a grounding electrode, shall not be smaller than size blank. So it gives you 4 AWG, 2 AWG, 3 AWG, and 6 AWG. So out of process of elimination, you students will learn, or if you don't know yet, or you're learning, that typically ground rods are going to be 6. Can it be smaller? I mean, bigger? Yeah, but typically 6. And then 2 is going to be your ground ring, typically. 8 AWG can be utilized, and I've seen it a lot on small services that are 100 ampere. Then you utilize it. But of a process of elimination, your answer here becomes pretty quick. If you're in an exam, and it doesn't matter to me at all at this point, anything else than what the code will actually tell me in a certain area of the code. So let's see who gets this. Let's see. Okay. So I've got Matt. Hey, Matt. Didn't see you there tonight. Yeah, I don't know, Tim. I don't know about the volume. I'm not doing anything different than normal, so I'm not sure. I've been getting muffles lately, so maybe I turned something down. Okay. Tim says 250, 52, 4, 4 AWG. Sandra says 4. Okay, sounds good. Tim says 4. 250.66b. Okay. Get a little different. Oh, Azil says 6. Okay, we have to have a little talk, Azil. Let's see. So I've got different code references. I've got a 250.52, and then I've got a 250.66. So remember, the question is asking about a grounding electrode conductor. So 52 is going to be talking about the electrode itself. So we want to be talking about the grounding electrode conductor. Okay. So in the back of the book, you could probably do a search if you didn't know these. There's certain ones that and when you agree, Vince, that I like to tell people, you don't commit it to memory, but there are certain things that you will just remember. Is it 250.66 for the grounding electrode conductors, 250.122 C1 and 2 when you're dealing, or C1 table when you're dealing with grounded conductors, supply side bonding jumper, system bonding jumper, main bonding jumper. Those are things that you'll just remember depending on, obviously, if it existed and what code cycle you're in. Things 250.122 for equipment grounding conductors. When you agree, those, however, I'm not big on having to try to over memorize everything, just know where to find it. But those are ones when you agree that you probably should remember.
Yeah, and I think most students do after rummaging around in the book enough and doing enough practice questions. It'll be committed to memory after a while. That there's a couple of tables, well, more than a couple. There's a good half view of tables inside the NEC that you will know the table number for automatically. They'll be burned into your memory. And this is a perfect example. This question is a 250.66 table 250.66 question. It's a straight lookup. It's really a softball if you put in some time studying. This would be a welcome question on a test.
Oh yeah, I'd love to get about 100 of these on an exam. The only advice that I can give to people out there that are studying is remember that there are certain types of electrodes that give you an allowance to be typically smaller than what we would say the norm. For example, if you have a water pipe ground, that's a straight pull from a table, depending, when you're looking at it, the size of the conductors that are supplying the service. But when it comes to things like rod, pipe, or plates, ground rings, and concrete encased electrodes, then you're able to utilize 250.66, and then you'll have an A, a B, and a C. So A, obviously dealing with rod, pipes, and plates, and B, dealing with concrete encased electrodes, and then C, I believe, ground rings. But you have the ability to deal with that. And all these are going to be a pretty easy lookup as well in the back of the code under electrodes. And you can find it there as well. But again, just get used to it. Vince is right. There's a certain number of tables in the code. Just if I had to rattle tables, 430, 248, 249, 250, 430 for the motor FLCs, the motors 430.52 for short circuit and ground fault protection. Just tables that you remember: 250.66, 250.102, 250.102 C1. Obviously, your 310s, 16s. Well, of course, if you're in the 2020 code. So, I mean, there's so many tables that over time, if you just go through a structured course, if you're just flipping through the code book trying to hope that you remember some things, you're probably not going to have that great a success. But if you go in there with a plan, so I believe that you at least get you some study questions, whether you use ours or whoever, at least it gets you into the code with a plan. And I think that your level of success is going to be a lot higher. So in this case, it's answering the question, concrete encased electrode, and it's 250.66b, as folks stated. And again, that's pulling from the actual options A, B, and C versus the table itself. If it was a water pipe ground, in-ground steel, things like that, straight from the table. Pipe, rod, and plate, if it's ground ring, or if it's concrete case electrode, you actually can utilize the options in A, B, and C for that. Okay.
Yeah, and I think, Paul, you would agree. We're not saying that everyone has to memorize the information on the table, right? We're saying, well, know the titles of them and what they do, and be able to get to the table to look up the answer, but at least know what table to get to quickly.
Yeah.
But not memorize the information in the table other than the title and what you can do with it.
Yeah, I mean, I try. I think that's a great point, because I don't ever try to remember the values that are all in those tables. Inadvertently, I'll miss something, and so for me, it's all a matter of getting me there. And then I've got, if you got 2 minutes per question, and in some cases, depending on it, you might have a little more, but it allows you to deal with it and work it out. And you get there, then you can look around and find your answer. Zeal question, bathrooms. I'm not sure what your question is, but everybody looks like, oh, you're already answering the question. All right, you're ahead of me. I do know what you're asking. All right, for dwelling units, panel boards are permitted to be located in all of the following areas listed except kitchens, bathrooms, garages, or hallways. Okay, this is again one that you should just be able to get it and move on to the next, the next question. This should be a real softball for you as well. Process of elimination. Nothing says it can't be in the kitchen. Nothing says, probably majority of them are installed in the garage. The hallway is fine as long as you have your working clearance and everything is good, working space, and you're good to go. I don't have any problem with any of those. Now the bathroom, that's a problem. The question is, where is it in the code? So Zeal, you gave me bathrooms, and on an exam you marked that and you went on and you did good. You marked it. It was one that you knew and you went on. However, where does it state that in the National Electrical Code? And let's see. Anybody? And while y'all are looking that up, looking real quick. Okay. I see a lot of bathrooms. Not Trey. Perfectly okay to have it in a garage. Let's see. Jamie says it's in 230.70A2. Okay. Well, I'm going to go to the NEC just because you brought up a reference. And what do you think, Vince? You think it's 230.70A2? I don't think so. But let's look.
Don't think so.
230.70A2. It might be. Might be one of the references. Service disconnect. Okay. Well, there you go, Vince. It says 230.70A2 says bathrooms. Service disconnect means shall not be installed in bathrooms. Well,
right. Like I said, I think it's 230.70A2.
Well, reason we'll say this is let's do this a little further here, because it's a good question and this is how they learn on it. Let's go back and look. Okay. The question was about panel boards. And so, that in your mind you're thinking, well, does that mean I'm going to be in 408? Or are we dealing with, so this is a good example of where you could probably get your answer at multiple locations. But what if I went to 240 and I believe 240.24? And let's see what that says. Because this is an example where I say, you know what, you probably can get your answer in multiple locations. That's specifically for the service disconnect. But what if I have the panel board that's in a remote distribution panel that is not a service disconnect? And if that's the case, if it's not the service disconnection means, are we here saying that, hey, just put it, the emergency disconnect rule now, put the panel outside, but you can have my remote panel, just put it in the bathroom? I don't think so. The rule is less about the panel board and more about the overcurrent protective devices that are installed in it. So in that case, let's look at 240.24. Location in or on the premise. And it says, and we kind of look down, occupancy, blah, blah, blah. And 24E says, not located in bathrooms. In dwelling units, dormitories, guest rooms, guest suites, overcurrent devices other than supplementary overcurrent protection shall not be located in bathrooms. So if you had gone down that path for the service disconnect, absolutely. Not in a bathroom. If you're thinking about panel boards and you're thinking about obviously panel board is the guts of the panel cabinet, which the overcurrent devices connect to. So that's going to put me in 240. And that's how I would have gotten here to 240.24E. Now, with that said, y'all know how I like to do it. I like to go over and look in 408, just because 408 deals with panel boards, and see if there is anything in here that would have gotten me that information if I had ended up there. Now, I wouldn't have gone there, but I can plausibly see how somebody would. So, I'm looking, here's panel boards, damp, wet locations, unless they're rated. That didn't really help us any. So it wouldn't have taken you very long in 408 to realize that you would have gone, oops, I don't need to be in 408. But I think you could have gotten your answer either way on that. But again, just keep in mind for exams that the question wasn't asking about the service disconnect, but it results in the exact same answer. So I'll do bathrooms, and there's the 240.24E. That was a good one to discuss. What do you think, Vince?
Yeah, I'll be honest. When I first saw panel boards, the first thing I did was I started flipping the 408 myself.
Yeah. And this one's important because you notice how it says, if it didn't say for dwelling unit, then only the service disconnect is not allowed in bathrooms. In a commercial building, I can have panel boards in bathrooms all I want. So that's important for people, because this rule in 240.24 only has to do with dwelling units. Now, I can tell you in my career as a contractor, I put a mini remote distribution panel in a bathroom. I did a large building which was nothing but Oriental rugs. And the rugs are so heavy, they were against the wall, that if you had put it behind these rugs, it could be argued that it wasn't readily accessible. So I had an outside service disconnect, and it came in, and they had a big bathroom, huge bathroom, plenty of clearance. And I put my remote panel in there, and the inspector proceeded to fail. And of course, everybody that knows me knows that I relish those opportunities to debate and have a good conversation, and called up the inspector and had him come back out. And he happened to have attended one of my training seminars, because I did it for all of the inspectors in the area. And he said, man, I thought I'd finally got you. And I said, no, you didn't get me, because I'm not putting a service disconnect in there. I'm putting a remote distribution in there. It's a main lug only, and it's got overcurrent devices in there. But if you go look at 240.24, it only limits it to dwelling unit. This is not a dwelling unit, so it was an other than dwelling. So this is how you've seen panels that are installed inside of a commercial bathroom. In your office, maybe it's the only room you have in your building. It's perfectly okay. You just can't have a service disconnect in there. So, interesting topic, in case somebody was ever questioned. Anyway, so he proceeded to pass my inspection and left. So, that was back in the day, Vince. All right, so next question. Disregarding exceptions. And you know what we always say about exceptions? Most of the exams that you take are going to tell you up front to not consider the exceptions unless they tell you to. But in our program, we actually do the opposite. We will actually let you use the exceptions and then tell you to disregard the exceptions to get you used to actually reading the question and not think about the exception. Okay? Which again is what you're going to do on an exam. They're going to tell you to not consider the exceptions. Okay, so it's a kind of one method of how we do it. So disregarding any exceptions when installing electrical metallic tubing, EMT, which is a raceway, by the way, and it is not a conduit. I don't know how many times I do get that from people. But it is a tubing system, and the run of tubing is required to be securely fastened at least every blank. 15 feet? Really? 6 feet, 20 feet, and 10 feet. So, what do you think? Let me make sure that everybody's seeing. Okay. All right. The answers are coming in quick now. I got John. Hey, John. Welcome to the stream. Oh, hold on. While y'all are looking this up, give me some code references. I got a question from William. Hey, William. Sorry to interrupt your exam. No problem. Trained electrician. Thanks you. And I was wondering if you have any advice on studying for the masters. William, I tell people all the time, don't buy into the gimmicks that people tell you. Exam prep for journeyman, exam prep for master. Here, I'll sell you a course for journeyman, and then when you become a journeyman, come back in a year and I'll sell you another course for master. A true exam prep course. Wow, look at all the people in the stream. Vince, you must be you, Vince. This is the most I've ever had in one early week session.
Great.
And we have over 50. So in this case here, I forgot exactly what I was talking about. Oh, the master's exam. Don't study for a journeyman. Study the NEC itself, because there's not enough differences that you should be segregating out residential from commercial. Just learn how to do it from the beginning. That way it's less, hey, Brian, I didn't see you in there. It's less, oh, my core strong is in here tonight. All right, there you go. It keeps you studying the code. There's no reason for you to be dishing out. That's why I promote it, and people think I'm self-serving, promoting our fast tracks. But, I've got at least a half dozen students in here that are in that program. You are free to say whatever you want, guys, about it. But the reality is you study with a purpose, and you study all the important information that's in it. It doesn't matter whether it's a journeyman or master's. Code is the code. So don't fall for those weekend crash for your journeymans, weekend crash for your masters. Again, I don't believe, I sat and helped write 2 exams for PSI, one in Texas and in Virginia. And I can tell you, we did not write questions that way. There were some of the questions that were on the masters that I thought should have been on a journeyman's. There were some on the journeyman's that I was like, that's a master level. Again, you have about 40 people in a room, everybody with their own egos, and everybody wanting to write the questions as hard as they think they need to be. And it just, I don't study that way. Just study the code. And whatever you did to get your journeymans, do the same thing. Okay? Yeah, there you go. Listen to Junior. He fell for that. Don't fall for that. You'd be surprised how many calls I get and emails I get from people who went to these crash things or went to these master and journeyman only to end up failing. It's just not the way to go. You want to be successful. That's why I do these things every week with you guys. And been doing it now for years. So, all right, I'm sorry. I got away from the question. So it looks like we have the answer, or people say 10 foot, 10 foot, 10 foot. Everybody says 10 foot. And it looks like everybody's got the exact same code reference. Okay. So we're not going to look that up. I'm going to go with the majority here, and we're going to say 10 feet. And there you go, 358.30A. All right. Enough of that. You don't get all that all the time. All right, so next question. Very good. Y'all are nailing them in here. All right. There we go. We've got something to do. It looks like we're okay. We're a single-phase 240-volt air conditioning unit has a single motor compressor with a rated load current of 35 amperes. What is the minimum size 75°C rated copper conductors required to supply the air conditioning unit? Oh, very good question. Probably one you get on an exam. We're air conditioning unit. So in my mind, what starts rolling around in your mind? Well, you've got the requirements of 440, which is HVAC. And in your mind, you're probably thinking, well, does motor come into play anywhere? Don't let that wander yet. Stick with the air conditioning aspect of it. And you know what it's talking about. It's basically talking about a branch circuit because, again, this would be a branch circuit that's running to the air conditioning unit. So it's a 10 gauge, 4 gauge, 8 gauge, or 6 gauge. Which do you think it is? And let's see. Yeah, Junior, for that same price, just about for that 2-day course, you could have got the fast tracks and you had access to it for 365 days and study at your own pace. Tons of videos. All right, let's see. Well, Trinidad says it's 10. Okay, give me some code references, and then I will help everybody out. What do you think, Vince? What do you think about when you see a question like that? It's obviously air conditioning, right?
Yeah, but you made a good point. You read a single motor compressor, and it could lead people to drift into Article 430 for motors.
Knowing that we know that you treat the AC motor compressor as a motor, especially when we're doing load calculations under 220.50, we treat it as a motor. And of course, we remember that all that does is send us to where it reminds us that we have to apply it as some type of load, a value that we apply. So what do you think?
Yeah, I think this one is probably the toughest question we looked at tonight to maneuver through.
Yeah.
Without having a little experience, if you've done the crash course like you've been talking about, weekend warrior type studying, you may just pass on this one, or pick C and move on, or pick your favorite answer and move on, and not get bogged down with this one.
Yeah, because you're in your mind, you're probably thinking, you're like, you know what? There's a certain number of questions. You know what? You do deductive reasoning and you look at it and you go, well, you see the 35 amps and you're thinking, what's a 10 gauge good for under 310/15B16 under the 75-degree column? And you're thinking, it's that. But then there's something else. So I see some answers here. Tim says 10 under 315. I think he means 310.15B16. We see Jay. And Jay probably remembers this a previous lesson that I did on this. Okay, because I see where he's going. And we've got Jamie says table 310/15B16, and he has a different size than what Tim has for that. And then Elwood gave a trigger, but I don't think I've seen, well, I have seen the accurate code reference so far. So let's kind of work through this one for you. So in this case, we're dealing with the air conditioning unit. The first thing that comes to my mind would be a branch circuit dealing in 440, right? So I could go look at the back, or I could go right to 440 and know that typically branch circuit applications are generally in the front, believe it or not, of a specific article. So, you can go to the back, but for us, let's just go on and go to the NEC. For those, you can see it here. And I'm going to go to 440 because I'm dealing with air conditioning. I'm not going to dabble in the motor. And so here I've got 440, and you've got your branch circuit. That's your definitions in the front. We don't have anything to do with that. And I'm looking at my bolds, selections, and everything. And I got single machine. And here we go. So I've got branch circuit, short circuit, ground fault protection. We're in part 3. And I'm just kicking my bolts. And then I get over to the branch circuit conductors. And that's kind of what we're talking about, right? So I'm going to highlight that. All right, so general, and then we have a single motor compressor. Now, let's look back at the question, because I thought that's what we were dealing with. Yep, we have single phase, 240 volts, a single motor compressor. Okay, so far it's looking good. All right. Then it says the branch circuit conductor supplying a single motor compressor shall have an ampacity of not less than 125% of either the motor compressor's rated load current. Very familiar. And you remember what we talked about when we were preparing for an exam? It's not like speed reading, but you look at the question and in your mind, you start repeating the key words out of there. Okay. The rated load current, the single motor, the branch circuit, so that when you're looking for the bolds, single motor compressor, the things stand out. Okay. So in this case right here, it's 125%. Now, For me, I would have remembered that, like I said earlier, in 220.50, when we're doing a feeder or service calculation, and I have to take the air compressors and other different applications, different motors, and at 125%, it's kind of where my mind was going with it. But I knew this was going to deal with 440. But 220.50 actually makes reference to 440 as well to treat the air conditioning unit. And we won't even get into that change for the AC unit in the 2020 220.62 or whatever it is, 61, about the AC versus heat. Maybe it's 60. I ain't getting into that tonight because I think the code panel screwed that up. In all fairness, enjoy. All right, so 125%, right? All right, let's go back to the code and let's apply it here and see what our answer would be. And so then we can choose an answer. So 35 times 1.25, that was 43.75 amperes, as y'all see on my screen. Then I'm going to go to 31015B16, and only then will I go there. And let's go to 31015B16, and I'm going to eventually have to start saying 31016 for everybody. But till then, I'll try to keep them both. All right, so here is 31015B16. Remember, in this question, don't let your mind wander. There was no adjustment or corrections. There was no mention of the number of current conductors. You'll get questions on the exam that'll ask you certain things, and you'll start to let your mind wander. Only answer the question as given, okay? Don't make it hard on yourself. Now, it did tell us 75 degrees C, so we're going to stay firmly in this, and it did say THWN, I believe, is what it said, but it said 75, so we're okay in this column. And it looks like I'm going to have 43. It looks like I'm going to need an 8 gauge for this application. Okay, so back to the browser and back to the people that answer the questions, and let's see what we got. Jamie gave us the code table, but I'm hoping that you got there from that method. Jay, absolutely 440.32, and that got you, and I'm sure you went and did the rest of the reasoning. Tim, remember, we kind of talked about this maybe in another episode about remembering that you have to be able to determine. And again, there's not sometimes, and I think what the problem is for some people is if you've done a lot in the trade, you know, if you're just getting into it and you don't have a lot of hands-on, then you have to dissect it. And like Vince says, this could make you pull yourself over to motors very easily because of the term motor in there. But in this case, you wouldn't. But if it happened to do that and you were crap out of luck on an exam and you're screwing yourself, and you can sit there and remember that most all motors, unless stated otherwise, are considered continuous duty. And so if that's the case, we're going to treat always at 125% for the single one application anyway. And if, so if your size and conductors in 430.22, we're going to go it and we're going to do it at 125%. So again, if you kind of screwed up, just remember it's pretty universal, the 125% for either continuous duty applications, continuous load applications, all of that. It's only when you get more motors than one that you have to start worrying about 125% of the FLC of the largest motor, and then the actual FLC of all the other motors. Then you only have to worry about that, and that's in 430.24 that you have to worry about that. So, what do you think, Vince? This is very plausible to be on an exam, you think?
Yeah, absolutely. Because there's a lot of room for going to the wrong spot and wasting a lot of time. Yeah. So they certainly throw a few of these in. Whether that's fair or not, I don't know.
Well, I mean, for me as an electrician, I need to know how to do this. Now, me and you both know the real practical application of this is what? It's the nameplate on the unit, right? I mean, at the end of the day, there's going to be a nameplate that says, what is it? Minimum circuit ampacity, maximum overcurrent protection.
Right. Yeah, that's all required to be on the label. Correct. Yeah, because all this equipment has to be listed, and as part of its listing, it's going to have a nameplate with all this information on it. But that, still doesn't negate having to know how to work through the numbers and find the answer in the book.
Yep. There you go. All right. For dwelling units, a branch circuit supplying receptacle outlets located in a blank is permitted to also supply readily accessible receptacle outlets located outdoors. So, dwelling unit, supplying receptacles in a branch circuit again, dwelling unit, receptacles located in a blank is permitted to also supply readily accessible outdoor. Now, first of all, I could probably do deductive reasoning here and realize that obviously bathrooms, you can't leave the bathrooms. You can't go out of that, 210.11. It's not going to permit that. So there, probably, you're obviously not going to do the kitchen, right? Because the kitchen can only do kitchen, pantry, dining, those type of things. So right off the bat, on an exam, I've done knocked it down to 50-50 chance. Laundry room, accessory building. Well, if your laundry room is designed on the laundry circuit and it only can supply the receptacles for the laundry circuit that are in that room, it's in the laundry room, then wouldn't you think, Vince, that I have a 50-50, the accessory building outside, if I supply the circuit outside, nothing should prohibit me from hitting other receptacles outside, right? So.
I agree, but you have to be familiar with the kitchen, laundry, and bathroom requirements. And if you're not familiar with them, then you have to work through all of them to get to the right answer.
Yeah, absolutely. So for reference, the circuit minimum circuit requirements are 210.11 for the bathroom, small appliances, and laundry. And also, of course, garage, if you have a garage, a detached garage or a detached with power. Okay. And then, of course, your receptacles and spacing is 210.52. Y'all should be familiar with that. And the accessory building is, nothing says you can't just have an accessory building to your building. Of course, you got to remember 210.8 GFCI requirements for at or below grade level. For those, anything that would be in there. So, but you're absolutely right. You have to be familiar with each one of these. So we're going to say accessory building, and there's the 210.11 reference, and there's the 210.52B. Well, we just said 210.52. Actually, these are your 17 references here. So this would have told you the circuits, and it would have told you that the kitchen, bathroom, and all laundry can't have any other on it. And then a 210.52B would have told you that you couldn't have anything as far as receptacles for the kitchen. I believe it's 210.52B. Let's go look. And Vince, I also realized that I didn't tell you how long I'd be on, so if you have to leave or anytime, it's perfectly fine. Just whenever you got to go.
How long are we staying on?
Sometimes I stay on for 2 or 3 hours. So
I'm putting in for overtime.
There you go. It's been an hour and 30 minutes. So we have over 40 plus people still in the stream. So
I'm hanging tough. Don't worry. I'm here with you.
Okay. All right. So there's your small appliance. So that would have been the one that would have told you that you could not have anything else. So logically, no other outlets right here. So small appliance can serve any no other outlets. So you wouldn't have anything else. So again, that's going to mean that the accessory building is the only plausible answer that you could go with for that one. And so while I was doing that, y'all were looking at me, and I forgot to put it on the code, and there's the code there for the small appliance. And the other one that we referenced is 210.11, and I'll show you that real quick for those that were asking. And there's your 210.11 right here. And here's your C, small appliance, your laundry, your bathroom. And of course, there's your new one for 2017, your garage, okay, requirement. If you don't have a garage, obviously that doesn't apply, but that goes without saying, I guess.
So Paul, this is probably the second toughest question so far after the previous one we looked at, because in reality, this isn't a straight look up and fill in the blank. This you actually have to have some familiarity with the at least two or three sections of the code and be able to put that information together.
Oh yeah. Yeah, I guess, yeah, because if you go guessing, then why throw away a question? Now, if you're a seasoned person, you immediately probably go, you can't take the kitchen out. But you're right. If you're taking an exam, you could eat a lot of time on this one, because you'd be running to 210.11, then you'd be running to 210.52 and trying to eliminate, because there's nothing in the code specifically that says accessory buildings can do this. It's everywhere else that says that those circuits can't do it. So yeah, that would eat you up.
Yeah, so really the emphasis on preparation, right? The more time you spend preparing and the more time you have your nose in the book reading and doing practice questions, the more prepared you are for a question like that.
Absolutely. All right, guys, next question. And those that are in the fast track, some will pull on you here. It says, when applying the general method of calculation for a dwelling unit, sure, I like that method. I would prefer it to, well, we'll go from there. It says, what is the feeder or service demand load in kW for one 8 kW rated residential electric range? Okay, so in applying the general method of calculation for a dwelling unit, what is the feeder or service demand load in kW for one? He said, never mind. Oh, sorry. For one 8 kW rated residential electric range, 6.4, 12, 8, or 7. So, he says, oh, yes, it is. Okay, so let's look at this one, because this is a great question, because immediately in our mind, I can tell you where somebody, Vince, what do you think? Well, first of all, let me put the table up, because I can see this right here being a really good exam question. Because if it's just asking you, hold on, let me see here. Let me go to the code book. If it's just asking you to figure, we'll go to 220.55. Okay. If it's asking you right now that it says, now, column C to be used in all cases is safe, otherwise permitted in note 3. Okay. So on an exam, it's an 8 kW. And we might go, well, wait a minute. It's not over 12. C is 8 for one appliance. It's 8 kW. But then we go to note 3 and it says where it's over 1 3/4 through 8 3/4 in lieu of the method in C. And this is the only time that we don't use C, but we always have to compare. It says it shall be permissible to add the nameplate ratings of all household cooking appliances rated more than 1 3/4, but not more than 8 3/4. Incidentally, I get this question a lot. If it's less than 1 3/4, you simply take the full value. You don't get into demand. Okay, that should be gone without saying for you preparing for an exam. But I don't know of any cooking appliance that would come across your quiz that would be less, unless they're just making one up fictitiously to try to trick you. Just remember, if it's less than 1 3/4, you take the full value of the nameplate. You don't get the demand for it. All right, so, but if it's 1 3/4, but not more than 8 3/4, then I multiply the sum of the demand factor as specified in column A or B for the given number of appliances, okay? And where it falls under A and B, which we don't have to worry about here, each should be added together and each done individually, and then you add the results together. Anyway, a lot of words. But reality is, does it fall under column B? What do you think? 3.5 through 8 3/4, and it was an 8 kWs. Does it fall under B? What do you think? You'd agree it does, wouldn't you, Vince?
Yeah, it falls. It's 8 kW, so it falls into column B.
Okay. So we have a C at 8, which is what it says the general, but in lieu of, because of note 3, and note 3 does apply to us, it's one appliance. We get to apply 80%, right? You agree?
Yes. It says it shall be permissible, so you can do it if you'd like to.
Right. So if you want to do it at full 8 kW and have a larger than necessary service and have to buy a larger than necessary wire, hopefully from Encore Wire, then you do that. And you install it in a Siemens panel. But if you don't and you want to do smaller, which you still can install it in the Siemens panel, but you got to go with smaller wire, then you can apply it. And you know what? I am very proud to say that the first one to answer that right away was Jay, and he jammed on it with the fast track student. So we'll go with 6.4. There it is. Column B. Well done. Well done, Jay. You like were right on top of that one. That was like, you were like on that one so quick it wasn't even funny. All right. Another question. Y'all ready? They're getting tougher.
They are getting tougher.
I
should move along here. Any kind of range question is usually tough to maneuver through, because that table that we just looked at, the 22055 table with all the notes at the bottom, is not an easy one to maneuver through.
Nope. And hopefully all of you out there that's listening have gone to watch my range calculation video on our YouTube channel, where I will break down every note and how you apply it. And hopefully you've watched it, and I'll even teach you how to deal with the situation where you have a 4-wire 3-phase and you're doing single phase ranges from it, and how to do that. Hopefully you watched that video, because I can guarantee you that question is on the exam. Okay, the one dealing with the single phase ranges from a 3-phase application, feeder or service or whatever. So make sure you go over there and watch that video if you haven't watched it yet. Oh, and also to remind you, if you haven't subscribed to the channel, please subscribe so you can get notifications, because I usually do this every Wednesday evening, sometimes 2 nights a week, like tonight. But also, you'll get notice when I do Electrician Live on Saturday night at 8 p.m. Central Standard Time. We had a great show last week with Jeffrey Mort was the guest, and hopefully you can go watch that. It was a great show. Jeff's a great guy. So, all right, next. Where a dwelling unit has a demand load of 8 kVA and a total of 6 branch circuits, the service disconnection means shall have a rating of not less than, wow, okay, 125, 40. Well, we can use some pretty good reasoning right now, and we're talking about a dwelling unit. So, but I guess we got to be careful, because it could be a dwelling unit in a multifamily, couldn't it, Vince? So
yeah.
I'm thinking about service ratings, and the service ratings 60 amps and then 100 minimum for 1 and 2 family or 1 family. So anyway, don't let the mind wander. We'll keep on it. So 8 kVA and total of 6 branch circuits. Doesn't give us anything beyond that. And the service disconnection means shall have a rating of not less than 125, 40, 60, and 100. Now we'll have to assume where the person writing the question is, but I can see where some would do this. They'd say, okay, it is dwelling unit, so we're going to assume 240. I mean, I'm just saying, this is where I can see people will go here. So 8,000 kVA, 8,000 VA, convert kVA 8 times 1,000 to, better to work in VA always. So 8,000 divided by 240, and it's 33.3. So I can see somebody thinking 33.3, 40 amperes. Boom. And that's where they would go. Okay. I can tell you right now, nothing about the rating of the dwellings aspects is going to allow you to do it 40 amperes. So you can get rid of the 40. So it leaves you with 125, 60, or 100. Even though this answer seems plausible to everybody, that would not be it. Okay. So you can throw out that reasoning to the question. That is not what they're asking. They're asking for the service disconnection means rating. So again, bunch of words there to calculate something, but I'm going to say that I don't believe they want me to calculate anything. Okay. So let's see what we got in our questions. I like the answers. Vince, I don't know if you can see the questions or see the answers that are posting. I don't know if you're on the YouTube one, but we've got 230.79C, 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 everybody's 100, 100, everybody says 100. And so to me, let's do it. There you go, 230.79C. Y'all didn't fall for it. So on an exam, can you not, Vince, can you not see somebody stressed out or is going to sit there and say, demand, 8 kVA. Somebody did a calculation already. I'm going to do 8,000 divided by 240. Oh, it's 33 point. Oh, got to be at least a 40.
Yeah, it's easy. It's an easy one to get suckered into to try and to start putting a calculator to it and taking a guess at 6 times something, 6 times what though? Would you add 6 times 1,500 VA or?
Yeah, I mean,
plus,
it doesn't say whether it's 15 amp circuits, 20 amp circuits.
Yeah.
So both the kVA and the number of branch circuits is basically to draw you in, suck you in, and then all they were asking for was the minimum size service disconnect rating that you can have, for the dwelling unit. Now, interesting enough is if it had said individual dwelling unit, then I probably would. Let's look real quick at the code because I would have said, well, let's look at 230.79 real quick because y'all all did excellent as always. But here's the rating of the service disconnect. So the trigger for us was it was in service. We knew that. So see how this says one family dwelling? And again, this says all others. So this doesn't necessarily say dwelling units. And we have a definition of dwelling unit. And we have a definition of one family dwelling. So again, but it's okay. The question was answered, but there's applications where the service disconnect means has a rating of 60 amperes. And I've seen this for the individual dwelling units of a multifamily dwelling, where this would qualify as it's not a one family dwelling. It is a dwelling unit, and that's what you typically see the apartments at a 60 amp disconnect. But that, again, wouldn't be a service disconnect. Typically, those would be feeder disconnects. But couldn't you plausibly see this, Vince, where I have a meter stack outside and they're multifamily building with individual apartments. They're not a one family dwelling. And so you could have outside the meter stack 60 amp breakers with each meter.
Yeah. And
I've seen it. So, again, probably not the best worded question, but it got us it got where we needed to be. So the way it talks about this with the branch circuits and everything like that and the service rating and everything, I probably would put where a single family dwelling has a demand load, and it would have made it easier for you. But it is what it is. We have to kind of go with the question. It's not a bad question, but again, even if you got this one wrong because you chose 60, it's okay because there's enough information here that would have helped you learn from even a wrong answer. And it doesn't make it a bad question. It just would have been, you would have learned from the question. And they were trying to sucker you in with this information right here. Okay. Service equipment for an individual mobile home. Okay, now they're going to say individual. An individual mobile home shall have a rating not less than blank amperes at 120 to 40 volt single phase. Okay, so service equipment for an individual mobile home. Where do you think you're going to go? Let's see. Yeah, Tim says he'd love to have 100 of those questions. Absolutely. You mean the previous question, not this one. So this one, obviously we're dealing with a mobile home. I mean, that's the core thing. So when I'm doing what we call the scanning, then I look at it. I'm looking at service equipment that's locked in my mind, kind of like a speed reader. Service equipment, mobile home. Two things locked into my mind. And then, of course, I'm seeing the voltages, the amps here, because that's going to be triggers as well, looking once I get there. But I'm thinking I'm going to be in 550, all right, mobile homes. And I'm looking for service equipment rating, okay? So that's where I'm thinking I need to be. Also, I'll remind you, I'm a big believer in flashcards. Y'all have heard me talk about it for years. The Fast Tracks program allows you to create your flashcards on the fly. Kind of interesting. I don't know if you knew that, Vince, but in the program, you can create a flashcard for anything. So I could go through and make flashcards for every table in the code to practice getting used to the tables. I can make one for all the articles. I can make one for all the chapters. I can make one for different parts. On the fly, I can make unlimited numbers of my own flashcards. And you can flip through them all the time. So it's you don't have to anymore. We don't have to do them anymore with index cards and all that kind of stuff. You can do them all right there in your program.
Yeah, it sounds like a great idea and a great option.
Yep, it's all built right in. All right, so let's see what we've got. Everybody's flowing them in now. I've got some 50s in. I've got 60. I got some 100s, and I got some 50 amps. And Jay went to the index under mobile home. Okay. How you do that, Christopher? Down on the right where you see the little icon, I'll show you real quick while everybody's giving the answers. Down here, you see the flashcards. You can click the flashcards, and up there it'll have a link up there that says create a new one. And you just create a new one, and you just type it in, and it'll flip over, and you type it in, and you create them that way. So again, it's all within the flashcards. All right, so this one is mobile home service. If you go to the back under mobile home, and we'll get you into services, we'll assume you did that. And we're going to go and look at 550. See what we got. I'd be very interested in seeing this answer. So I just did a video on some of this type of stuff. So anyway, so I'm over here, and I didn't go in the back. So we're using our bold scanning technique, and we're looking for those keywords. Remember, it's service. We're looking for the service equipment, application, and Ampere values, and they'll stick out. They'll look like Ampere values. Okay, so I'm going to scan through it. There's a mobile home, but that's just giving us our definition. General requirements. Okay, and I'm going down, and here's the power. Okay, but this is power and feeder application. Doesn't necessarily tell me it has anything to do with service. If that's where everybody went. See what this says, 50 amperes. I'm assuming some people went there for the power cord. I keep looking down, and I'm looking for service. There's the branch circuits. There's small appliance if you want to do your calculation for mobile home. You have two options. You can do that. How to do that? If you don't know everything, you can use 16,000 VA, or you can use the application and treat it just like you would a standard calculation. Two different ways to deal with it. And so here I'm going in. There's your calculations, 550.18. And I'm looking, and I'm trying to hit, there we go. Part 3, services and feeders. Service equipment. Okay. That's pretty, looks like I might be in this where I need to be. Rating. A mobile home service equipment shall have a rating of not less than 100 amperes at 122.40 volts, and provided shall be made to connect the mobile home feeder assembly by a permanent wiring method. That's basically, you have a separation. It has to be at least within 30 feet, okay? But not more than 30 feet and within sight. You have it, and then you can transition from there. That's where your service disconnect will be. Then it'll go in. Your remote distribution panel will be in your mobile home. Okay, it cannot be, it has to be adjacent to the mobile home. It can't be mounted or in, so it's why you see it. But it can't be not more than 30 feet away from it, and it's got to be within sight. Okay, so again, 100 amperes. see. Let's look back at what options everybody chose. And it looks like straight to 550. That's what Tim did. Scanned the bolds and got there. 550.32C. There you go, Mandingo. And everybody was right when it comes to the 100 amps. Well, I don't know. Are y'all right? Except for a couple said 50 amperes or 60 amperes. But no. Let's do 100 and see what our answer is. There it is, 550.32C. And that's where we were at. It was 100 amperes. So the cord and plug application for it is different, because that might have a lot to do with the fact that usually you have a calculation if you have what's called a mobile home lot, and then you get to do an overall calculation for the mobile home lot, and that calculation is different. And if you do the pedestal and you do everything, then you could have a mobile home come on it, and you could supply the mobile home with a cord, and then you have minimum cord and ampacity values as well. Most of the time, the mobile homes that are going to have, that are fixed in place, we're not talking RVs here. So a mobile home is fixed in place. It's probably going to have its own service. It's going to have a pedestal, and it's going to have the service disconnect, the meter there. And then, of course, then you have a feeder that's going over to the actual mobile home. Okay. What do you think about that one, Vince? Was that a tough one? Not really.
No, that should actually be, I don't want to say fairly simple, but when you have a specific reference to something like a mobile home, it really should, set an alarm off in your mind that you're going to go to one article and one article only.
Right.
To address that. Same would hold true for something like, if you have a question about an elevator or escalator, well, there's really only one article in the NEC that deals with that. I believe that's 620. So you should be able to get very close to the information you need fairly quickly. Swimming pools, another good example in Article 680. So, an obscure question about something very specific is actually helpful sometimes.
Yeah. And I think what some folks did in the room was they probably went and saw that 50 amp. But remember those key words? We were dealing with service equipment. So something has to say service equipment in it or something to that nature. And the first one was the cord and plug. That was basically feeder applications. Okay, so that didn't say anything about service. So you want to make sure that you're picking out the root things, whether you're using the index or whatever you're using. There are, and hopefully you've watched my video that I do on how to identify the root of a question, because again, it'll help simplify this a lot if you utilize that little video that I did on how to identify the root. It will help you try to dissect it. Next question. For 15 and 20 amp branch circuit, the rating of any one cord and plug connected utilization equipment not fastened in place shall not exceed blank of the branch circuit ampere rating. Now, Vince, this is a classic example of, we had a question earlier, and you might have an exam. This is kind of what I tell people on an exam. You're answering these questions on the exam. If you mark something, later on, you might get a question that kind of, you already been there, you already looked, and you remember it, and you're like, oh, crap, I know exactly where to go. Because we had one that dealt with cord and plug connected appliances. Right? So this is very similar. And so if I was on an exam, I might be able to say, oh, I get this one right away. Okay.
Yeah, and it's a double down on branch circuits. I see it twice in the question. So that, 210, Article 210 pops into my mind right away as a spot to go take a look.
Yeah. So in that case, I'm thinking, again, one of the things you could do is go to branch circuits in the back, and I'll see if with their answers, Jay, any of you want to, I see a bunch of code references, and any of you, Jay, tell me how you got there and what you did. Did you go to the index, or did you just go there because of a previous question and you remember that we went there? Because I see people giving two different answers here. I still see it. So I've got about 10 people answering, and Jay made a statement. He says, I can't stress to all you guys how the fast tracks has improved my code navigation. Again, it definitely will. The more you do it, and that's the whole nature of the application, the whole nature of the Fast Tracks program is to do that. Mind repetition. I refer to it as ballistic training. Why? Because you hear it, because you remember it has an audible feature to read it to you. And you can actually, when you highlight it for it to read it to you, it actually bounces on each word. So that if you read it as it's going and you hear it, it's kind of like ballistic sensory training. You get to, it's easier to memorize. Okay. So in this case right here, it is a 15 or 20 amp. Me, like Vince says, it definitely calls out branch circuit to me. Now I remember earlier we were talking, and as long as it gets you around there, I remember we were talking about 210.23 and 210.20. Remember we were talking about that 80% for that cord and plug connected appliance application. But if I remember right, it didn't actually say appliance, which again is appliance can be utilization equipment. But I remember it having that language specifically in 210.23. Although I could go under branch circuits, and I'm sure that in the index it's going to have the same thing, because remember branch circuit listed this, and that's how we got there last time. The same method, if I remember right. So in this case, I want to go to the code book, and I think that where I'm going to be is in 210. Like Vince said, we're going to be in 210. But I think we're in dealing with branch circuits. I think we're in 210.23. And let's see if we are. Yep, it was 15 or 20 amp circuit, cord not fastened in place. And I think that's what the question said. So let's look at the question again. Cord and plug utilization not fastened in place shall not exceed blank of the branch circuit rating. Okay. So there is what we say. Cord and plug not fastened in place. The rating of any one cord plug connected utilization equipment not fastened in place shall not exceed 80% of the branch circuit ampere rating. Boy, a direct straight pull from the NEC. Okay. So there's your answer, 80%. 210.23A1. All right. Next question. Where a mobile home has a main service disconnecting means installed outdoors, the disconnecting means shall be installed so the bottom of the enclosure is not less than blank above the finished grade. Interesting question here, because we have so many rules in the code about the height, width, depth, all this, but we have nothing in the code except for one location in the code that talks about how low it can go. And this is it. And so, and again, people ask me all the time, how low can you put a panel? I don't know if you've seen you have little people, they need access to it as well. So you could put it down real low. I mean, there's some little people. So, and then of course you have ADA requirements for certain things. But in the code, we tell you that you can't be higher from main breaker, 6'7" to the middle of the main breaker. You can't go, or any overcurrent device can't be higher. And, you have clearances. But where do we have it that has, whereas you can't put it too low? Now, of course, for me, I'm thinking the triggers here are mobile homes. I'm thinking the trigger is service disconnection means, okay? And of course, remember I said about memorization when it comes to reading the question and remembering when you go to look it up, not to memorize the code, but I'm also remembering that it's talking about bottom of enclosure. So that's in my mind. So I'm thinking mobile home, service disconnection means, bottom of the enclosure, all those things. And then once I'm there, those are rattling around in that hollow space of mine anyway. And I get there, and now I remember 3 foot, 2 foot, 4 foot, 1 foot. I'm looking for some foot reference, feet, whatever. Okay. So if I'm doing that, I'm thinking, first of all, I'm not going to spend a lot of time going in the index here. Mobile homes is not that big, and I'm dealing with service disconnecting means. Okay. So I'm going to probably go right to 550. And like Vince said, sometimes it's just much easier just to go right to it. You could spend a whole lot of time flipping around in the back, but there's I'm here, and I'm going to go through the bolds, And one thing that sticks out to me is a foot height reference, you know, the 2 feet, 3 feet, 4 feet. So that's kind of something as I'm scanning that I'm looking for. I'm also looking at, again, as in the question, all those different triggers that we were looking at are just kind of rolling around in my mind. So we're talking about the disconnection means. Okay, so I'm looking at here. Here's a disconnection means. And I'm looking at it, and it says clearly mark the main. Okay, I'm turning the disconnection mean equipment shall have a rating not less than a calculated load. Okay. The distribution equipment, either circuit breaker or fuse, shall be located a minimum of 24 inches from the bottom of such equipment to the floor level of the mobile home. Okay. In my mind, I'm thinking, you know, well, I see this 24 inches, and that was one of my things. But me, I am always the ultimate skeptic in a sense that I'm thinking, well, that's my best answer to go with unless I'm looking around for something to do with service disconnect. So I am going to real quickly scan. The last thing I want to do is get one question because I said good enough and I moved on. So I'm going to look, and I remember there was dealing with services. So I'm going to, here's services and feeders. And here's the service. And I'm looking to see if there's anything in here. Here's your rating. Mounting height. Okay, remember this is under services. That was a trigger for me. Now, if I stopped at the 24, am I going to be right? I might got lucky, but I don't know. We have to look. So then I get down to wherever I was at, mounting height. Outdoor mobile home disconnecting means, and remember something. Remember what we said? The service disconnection means cannot be in the actual mobile home. The other one we were looking at were disconnection means in the mobile home because it's talking about the floor level of the mobile home. So you should have not been there. You're thinking service, and a service can't be on or in the mobile home. It has to be adjacent to it, not more than 30 feet, and within sight. So your mind could keep going. Now, let's just see if we could be right. It says that outdoor mobile home disconnect means shall be installed so at the bottom of the enclosure containing the disconnection means is not less than 2 feet above finished grade or the working platform. So I think we know my answer now. Okay. But do you see where that could, I mean, luckily you came out. Now, this is one thing that I harp on the guys on the exam prep stuff all the time. And Jay and Tim and all of them will tell you this. Don't make a mistake and answer. If there had been 24 inches down here and you chose 24 inches, it would have been wrong because the answer said 2 feet. And so in our program, I mark it wrong. And Jay, Brian, and all of them will tell you, if it's asking you for feet, you better give it in feet. If it's asking for it in inches, then you better give it in inches. And I will mark it wrong because you need to start. What it tells me is you didn't fully read the question. Okay. And so again, and in this question's not a great example because it didn't say feet or inches in the question. But a lot of them in our exam prep are competency reviews, and the competency reviews are tough. Ask any of them that are in the Fast Tracks program. Those have to be, Vince, these are tough. But I have never yet shown you competency reviews that we have for each unit. Those are tough. You cannot choose A, B, C, or D. You actually, after you do the unit, you have to be able to answer the question without an optional A, B, C, or D for the most part. So you have to fill in the blank, and you have to give me code reference. So you can imagine there's over 1,200 questions in this program. How do you not pass the exam if you go through the Fast Tracks and you really put the time into it? It's almost impossible. I mean,
yeah, it sounds like a great study technique, which is what you should be doing anyway when you do these questions. You should be coming up with an answer, and you should be writing down the code reference number.
So there we do. Let's do the 2 feet. And we got the screen of death that I got the other day, which is probably a good sign to end. And this isn't from the, watch this. This isn't from the Fast track. See, this is 18.2. Watch this. I did this the other night. This is what happens when I stall online. It doesn't happen to the people that are in the program. When I do a lot of running my mouth, like I do a lot, it causes, see, okay, why are you doing that? Did y'all hear my dog?
I hear him.
Hear my dog? It's literally the loudest dog you ever seen. 2 of them, actually. And one of them's getting fixed tomorrow. Because I'm not into having puppies. I already had a kid, and that was bad enough. All right, so back into this one here real quick, guys. And let's see if it brings us back where we left off. What is it doing here? Bear with me. We might be ending it early tonight. Well, I wouldn't say early. We've been here for 2 hours. But I noticed that it kicked me. No authorization. They done kicked me out of it, y'all. One more last question. Let's see here. That's on their end. There we go. Wait, that's a totally different question though, isn't it? No, it wasn't. There's the 2-foot. There we go. Okay. Vince, can you still see it?
Yeah, I can see it on Zoom. Mm-hmm.
The test questions? Okay. I have no idea what happened with that. So anyway, okay. I think we got everybody. So we'll do, hey, somebody asked, Jay says, can we recruit Vince to Team Core Strong? Well, Vince is always welcome to come in on any of these streams and chime in and whatever he wants. He's more than happy to join me anytime. He's actually one of the very few that I do like. Or like me, I should say. Well, I think he does. I don't know. We'll see.
Most of the time I do. Not right now, no. Pushing 9:30 at night.
Oh, it's 9:30. He's on the East Coast. That's right. So, all right, last question, guys. Again, hey, Kevin's on here too. Yeah, fast tracks are no joke. In fact, to prove that, well, I won't do that. I won't do that tonight. Answer this question, and we'll call it a night. It's been a long day for everybody, and Vince has passed his beauty sleep. A GFCI protected receptacle outlet that provides power to a permanently installed swimming pool recirculating water pump motor shall be permitted not closer than blank feet. Oh, we end this on a pool question. Okay. Closer than blank feet from the inside wall of the pool. Now, interesting enough, we have receptacles, general receptacle clearances or spaces, and then we have a whole separate thing when it comes to swimming pool recirculating water pump motor receptacles. Okay? But obviously, first thing that this would happen for me, it would tell me right away that I'm in, obviously, 680. No brainer. And my code making panel 17, you would agree this should be 680. Says pools.
Yeah.
Swimming pools.
Yeah, like I mentioned earlier, this is it's a good question to get you to the right spot pretty quickly, because if it's a pool question, you're definitely going to be in 680. And once you get a feel for the layout of 680, you'll see that there's different parts to it. And part 2 specifically deals with permanently installed pools, which is in the question. So that gets you even a little closer to where you should be for the answer.
Yep. So part 2 and part 3 is storable. Part 4 is hot tubs and spas. So we keep, part 5 is fountains. We keep moving on down the line. And so, but we know where we need to be. So that can really shorten your time. See, that's the beauty of studying, because at this point now, I do see some questions coming in, or some of the responses coming in, and I've got 2 different responses. Let's remember, we're going to be in part 2, and we're talking about the receptacle. We're not talking about the maintenance disconnect. I see somebody made a reference to 680.12. That's not what we're talking about. There's nothing in here that said anything about the disconnection means. So it's just very much receptacle driven here. Okay. So let's go to the code. And let's go to 680. And we're going to do what we just discussed. And we're just going to say, if I was in an exam, I'm going to go to part 2. And this is where I'm at, part 2. So just so while we're here to show you that 680.12 is equipment rooms, and or 680.13 is a maintenance disconnect. Not so sure why. I thought it was 12. But anyway, so that's obviously not what we're talking about, right? So now when we're at part 2, we know it's nothing to deal with the motors. So we're skipping that bold. Here, 680.22 is lighting, receptacles, and equipment. All right, so we've got that. Now, quickly, since we knew it was receptacles, we got the regular ones, which you heard me talk about a minute ago. And then you have what's called circulation and sanitation systems. So receptacles that provide power to water pump motors or for other loads directly related to the circulation and sanitation systems shall be located at least 6 feet from the inside wall of the pool. Okay, a couple of cycles ago that was 5 feet. So 6 feet. Okay, so if we go back to our code, to our question, and we got 12, 5, 6, and 15. We know it's not 15. We know it's not 12. The answer is either 6 or 5. We saw absolutely nothing with 5, although we did notice that this is a good way to throw this in there. You would see 5 feet for the switches, for example, or you would see 5 feet for disconnects or things like that, but not when it comes to receptacle. It's going to be 6 feet. And 680.22A2 from the 2017 code. Absolutely correct. And let's see what our answer is here. 6 feet, 6 feet, 6 feet, 6 feet, 6 feet, 6 feet. There you go. Good, good, good. Okay. What did Jay say? Jay say, darn it, scanned too fast and missed that subsection. I believe that's the proper term. Subdivision. Call it subsection, be fine, but it's called a subdivision. But what's the difference among friends? Subdivisions, subsection, it's all good. That's all good. It's not like I'm going to berate you over subpanel and whether one exists or not. Okay, we'll leave that for others to argue. All right. I couldn't help it. I had to do one more. Vince. I couldn't help it.
You're killing me.
All right. Last one. All 125 volt single phase 15 and 20 ampere receptacles installed in laundry rooms of a dwelling unit must be provided with a GFCI protection where located blank. Anywhere in the laundry room, within 6 feet of the sink, within 8 feet of the sink, within 4 feet of the sink. So, what do you think? Now, you're thinking sink, and you're thinking, oh, I remember something in 210.8 that talks about sink. Now, this is 2017 code, so you're thinking, But something significantly changed a cycle ago, and when it came to laundry, we removed the sink even being part of the equation. So if you were thinking about this for an exam, you could do good deductive reasoning to come up with this. And so I see some folks that say 6 feet. No, within 4 feet. I see that. And again, DJ probably answered just right off the cuff, right? Just answered it. And this would be somebody who's possibly on the 2014 code that hasn't made it to the 2017 code yet. And it used to be hingent on the sink, but it's no longer the case when it comes to the laundry rooms anymore. It's all of the 15 to 20 ampere are going to require to be GFCI protected. And if you're in the 2020 code, then that dryer is also going to be Also going to be GFCI protected once you get to the 2020 code, because we know how the manufacturers need to make that extra buck.
Come on. And now that you kept me later for this one last question, that should really say laundry area and not laundry room.
I didn't write the question. But you're absolutely correct. Laundry room should be laundry area. Good old, you know who wrote who these came from? Charles Miller. I'm going to send Charles a text and say, Charles, Vince Delacroix.
I'm sure he wrote these based on what edition? He probably wrote them based on the earlier editions also.
Yeah, well, this is 2017, so it would have been area. So I can literally give him crap. He's already still mad at me over something else I did, but all good, all good.
You probably keeping them late on a conference call one night when you said it was going to be quick.
Did I say this was going to be quick? Sorry. All right, so I see people throwing references to 10.8A7 in the 6 feet. No. It is no distance requirement when it comes to the laundry area or laundry room. Okay? So.
Yeah, you got to read past parenthesis 7 that talks about sinks and go down to parent 10 where it calls out laundry areas.
Yep. So
that's easy. It's an easy one to get tripped up on, though. To go to the sink reference.
Yep. Because you see the sink and then you go right to the sink and you're like, I'm done. And you're on an exam, right? And you're already stressed out. You know you got this little clock ticking up in the corner and you're stressing out for the exam. So what is the best way to reduce stress for an exam? Be prepared, right? Just know the code and be able to look it up, be able to maneuver it, be able to pull out the root terms. At least half the battle is won if you go in there and you're not stressed about it because you're prepared. You did it right. Not a crash course weekend, not wait and say that I'm going to get my code book and start flipping through it and then 2 weeks from now go schedule your exam. That ain't the way to do it. That ain't the way to do it. You need to prepare. So Fast Tracks program is the way to prepare. And with that said, I know I got to let Vince go, but I wanted to show him real quick the competency reviews and what that kind of looks like. So you kind of see what these guys have to go through, Vince. I don't know if you can still see the screen.
Yeah, I can.
You see that? Unit 11?
Yep.
So again, they have to answer these questions. And here you notice that it gives them some values for a dwelling. And then they have to answer these associated questions that have to do with calculating out this dwelling. And then they have to do the same thing for this one. This is a 6-unit multifamily dwelling. And they have to work it out. And it's the way they come up with these answers. And then they submit it to me. And I will grade them. And I will give them feedback on how they did. Here's what is the dryer demand load in KW for 25-unit multifamily dwellings with a 4.5 KW closed dryer in each unit. Services a 12240 single phase. So again, 4-unit a complex with a range has a 15, a 14, a 10, and a 9. What is the KW demand load added to the service by these ranges? So it's really a lot of questions. And here's another one, 18-unit multifamily. So if they go through this, and you notice there's not an A, B, C, D option here. They have to literally, what they'll do is they'll click on this and they'll type in their answer to me. And I don't know of any program, I mean, you've been around, a lot of people sell books, a lot of people have DVDs, a lot of people have different stuff. But what do you think about, just from what you've seen here, what do you think about these questions? You have to literally work them out.
Yeah, and it's a great way to prepare because I could tell you, and you mentioned, and when we started off tonight, that I recently took an exam, and I did. I took the state of Washington They don't call it a master's exam. They call it a electrical administrator, I think was the name of it. But it's equal to any master exam in any other state. And those are the exact type of questions that were on the calculations part of it. So they're certainly not, you know, by any stretch of the imagination, and off the wall type questions. Those types of questions are definitely on tests and the calculations part, and you have to know how to work through them. So there's only one way to do that, and that's to put your nose to the grindstone, pencil to paper, and calculator, and be able to maneuver through them.
So those that weren't familiar with the course material, see the flashcards? Somebody said earlier, these are the flashcards I was talking about, Vince. So they'll come up, say, and it says, and you can make your own. See, create a card. So I could create a card, and I could put, let's see, Article 100, and I could put definitions. So Article 100, definitions. So I can create it. Next card. Minimum calculated load for electric clothes dryer using the standard method, 5,000. Oops, got to go back. Previous card. Got to click it. 5,000. So again, you go to the next card. 2 methods of calculating service loads. Standard and optional method. Standard and optional method. Calculated load for each small appliance branch circuit, 1,500 VA. 1,500 VA. So you can create any number you want, shuffle the deck, percentage of range neutral load used for neutral, 70%. Right there. So you get used to it, and you can create as many flashcards as you want. And everybody's watched my video where I talk about creating them for parts, for tables, for sections, for create your flashcards, and just, it doesn't matter if you don't know the answer. It's still flipping it. You'll get used to it. Okay. Percentage of continuous load used to size feeders. So you're like, okay, I don't know what that means. 125%. Okay, now percentage of continuous load, 125%, which incidentally is the same for a branch as well for continuous load. Doesn't change. So, I mean, there's just so many things that you can do with these flip cards, and there's literally flip cards, as you can see right here, for every unit. And you can make your own as well.
Yeah, so my recommendation would be for if you're going to make your own, don't just put the answer on the back, but put a code reference also.
Oh, yeah. Yeah, that way you get used to seeing the code reference.
Right, the answer plus the code reference. And having the reference down reiterates the fact on where it is in the book, and helps you to not only, you know, cross-reference those, but also reiterates what article relates to what, you know, code topic.
Right.
And that's all that reinforcing of, you know, being able to remember that table 250-66 is dealing with grounding electroconductors and sizing, and table 251-22 is for sizing equipment, grounding conductors. And that's what you need to know, and then be able to get to the table, and then get the answer off the table. Like we said earlier, not memorize the whole table, just the title.
Yeah. And if you're really dedicated to learning, and you want to not have to take it 4 times, you want to get it done. We have a lot of people in the program that aren't just preparing for exams. They just want to learn the code better, because again, we only get paid to do it once. We don't get paid to do something twice. So understanding the code is going to help you in your job, in your business, as that head guy, that lead guy, that owner, all those type of things. It helps prepare you to be that guy, you know, that go-to person. All right, we're going to end it. Most of you are probably familiar with the other stuff, and Vince is probably not seen it before. But like the reading material events, this is when I say ballistic training to people. It's this. See this? There's forms that actually teach you how to calculate every aspect of the calculation in a fill-out form, and we walk you through how to fill out each piece of the form. But the ballistic is that you can highlight it like this, and then you can click read text.
The term appliance designates utilization equipment, commonly built in standardized types and sizes, installed as a unit to perform specific function, parentheses, S, and parentheses Article 100. The term applies.
So you read it and it bounces along and you follow along and you just retain it. So it's visual, you hear it. And so there's just many ways that you can achieve it that way. So that's one of the things we do with it. And then of course there's huge section tests, and these are graded. You have 1 hour.
Mm-hmm.
And there's at least 100 of those questions in those different questions. There's tons of questions for everything. I'll let you go, but we had a couple questions that people asked. Let's see here. Honesdale says, where would the laundry area end? I would think it would end at the laundry area ends at the laundry room or the laundry area in that area. I would think the threshold of that room is going to be where it ends.
Yeah, you know, Paul, that's a good question because I had some conversations about that too. And I was back up to where I come from in New York City this past year because I'm on a technical committee in New York City. They're moving from the 2008 to the 2014 NEC in one fell swoop later on this year.
What's the matter?
And,
you couldn't get him to jump to the 2020? What's up with that, man?
They're lucky they're doing a double jump there from the 11 to the 14, which is big. But in some of those conversations, one of the guys on the committee brought up the fact that there's a lot of, specific to New York and probably some other major cities, there's a lot of small little apartment / lofts, and they are 1-bedroom apartments that are only a couple of 100 square foot, and it's one big room.
Mm-hmm.
And it's that one big room is everything. It's the kitchen, it's the bedroom, it's the laundry room or laundry area, and there is no dividing line where you step into one room or one area into the other. It's just one big square room. So where does that laundry area end or begin, or where does the kitchen begin and end?
Right.
And it's and that little occupancy, it's tough to determine where these things stop and start.
Yeah,
So, I think most of us think, and we think of a room as the laundry room, or maybe we have a washer and dryer in our garage, and we know that that's where, that's the laundry area. But if you think of little loft studio apartment, it's tough to determine where it stops and starts possibly.
Yeah, and I can see that what I would probably say if I was, the administrator for the state, or somebody came to me and asked me how would I make this easier for people, I would probably say, let's keep it simple, stupid. The circuit that's running to the washing machine, that is your laundry circuit. It stops. The circuits that are running to the kitchen that serve the countertop, stops. The circuits that are coming in to serve the main area, that's your 210.52A. And that's what that serves. So I would probably identify it out specific to make it, to try to keep it what it is. I'd say that's designed, since it's one big room, be honest with you, the small appliance branch circuit requirement serves the countertop. Now, can it serve the rest of the receptacles in a kitchen? Absolutely. Can it serve a dining room? Absolutely. But we have to look at the predominant use of space. So if I've got a countertop, my small appliances are going to serve that. If I've got that, it's facing an open room where I'm now going to have a sofa, couch, and then that's the predominance of the room. I would use 210.52A, and that would be my normal general application branch circuits, general purpose. The laundry, specifically for the laundry, and again, if I lucked out enough and it didn't have a laundry circuit at all, and it was an on-site premise laundry, then I don't even have to calculate the laundry circuit in there. Only if there is actually a receptacle there or a circuit there is necessary, right? In 210.52F. So at the end of the day, I probably would segregate it out like that. That's be the only logical thing that I could think that somebody could do. But again, you're right. It's going to have to take somebody actually formalize that and say, this is how we're going to do it, and this is the way we do it. And I guess that leaves it to AHJ to come up with how they're going to do it.
Yeah, you definitely got to plug some common sense into it. But, as well as I do, it's tough to to craft the code language to address every possible scenario and every occupancy out there across the country. You know, from where you are in Texas to where I'm here in Florida to the folks up in Alaska, and have the language explicit enough to be safe, but broad enough to deal with your local, specific local conditions.
Yeah, and I probably would look at it as an inspector up there. I'd probably look at it and go, you know what? Does it really matter if the kitchen, small appliances also branch out into the living room space? I mean, if you were really, at the end of the day, they're all protected by the overcurrent protective device, right? The load is going to be limited, right? So it doesn't really matter. Even though the code tells us what we got to do, if somebody did that, I'm not going to, I'm not going to freak out, because it doesn't reduce safety. You know, it's 20 amp circuit's a 20 amp circuit. Yeah, it's supposed to serve the countertops and the wall, any wall spacing in a kitchen. But if it picks up a receptacle or two that's not in the kitchen because I'm blurring those lines, is because nobody can define the areas, and you can't really reject somebody for that. You can look at them and say, well, I think that at an angle, this part is still the kitchen. So unless an engineer does the drawings and actually sections off all the locations, which I'd probably tell the engineer to do to save me a bunch of grief, I'd say, hey, draw a little line of where you think the laundry ends and where the kitchen ends and where the living room ends. And then if any of the receptacles fall within those areas, we'll treat them at those circuits, somehow. Otherwise, I'd do it like I said it. And if I was in charge, it's just going to be the way it is. That's it.
All right. Well, I think we've veered off the exam prep topic.
Yes, we did.
I'm hanging. This is getting late for me. So
okay.
Thanks for the invitation. Hope
thank you
I
for
enjoyed
coming.
it. And we'll do it again some other night.
Yeah, definitely. Thanks for coming. And for those that are still in here, I'll hang in the stream and then end out with you. But let me get this up for Vince here real quick. And I am not sure, Vince, how to cut this thing off.
I'm going to try and hang up from my end. I don't know how, but...
Wait a minute. Hold on here. Because I got so many things open. Oh, there we go. I figured it out. Okay. All right. So I'm going to hang you up, and thanks for coming, Vince, and we'll do it again. And everybody in there say thanks. They're all saying thanks to you, Vince. So thanks for coming in.
Yeah, my pleasure.
Enjoyed having you in here. Take care, brother.
All right. Good night, everybody. Take care. Bye.
All right, guys, hang on there as I end that. Just trying out something new. So let's see here. We got any other questions I'll answer before we go? I think Vince. Vince is my buddy. He's from down in Florida. He's a great guy. Let's see here. So hopefully that helped you out, Honesdale. Any? JW, last year Hawaii moved from 2008 to 2017. Wow, that's a big jump. Journeymans who moved out there told me the board was concerned they weren't familiar with the old code violations. Okay, old code versions. Yeah, so a lot to learn when you're going to jump from 2008 to 17. I mean, you have from no idea at all what an arc fault circuit interrupter is, except for barely knowing that it has to do with bedrooms, to all of a sudden it's everywhere, So there's a lot of changes, a lot of GFCI changes, and just that you might not even be aware of. Good night, Christopher. Again, we're going to have one this week, and it's going to be, I think, Wednesday evening, and we're going to do voltage drop. Okay, going to cover all kinds of voltage drop stuff. Okay. So let's see, what other question? I didn't have any other questions. Okay. All right, for anybody that's interested in the Fast Tracks program, check it out. It's got a lot of good questions, a lot of good exam stuff in it. Give it a look. It is over on our masterthenec.com. Okay. you will, I don't know if there's any other program that's like it, to be honest with you. Okay. So yeah, we're going to, it's Wednesday night. I think today's Tuesday. So Wednesday night is probably going to be, typically what I do is about 7:30. If you're a member of my Facebook page, you'll see me post it. But I'll try to get it up there early. But we're looking at about, typically I do it about 7:30. Make sure you subscribe to the channel so that you get the notices, because it will send you when I'm live. And that'll give you enough time to get in here. If you need help with voltage drop, we'll talk voltage drop. And again, if you have any code questions, and hopefully I'll get everybody caught up when it comes to some of the questions that came in for the fast tracks that you guys have that are in the room. I've been so busy. I'm trying to catch up on everything. So I will do my best. And Dingo had a question. So I came across some plugs. Plugs be slang. Slang for receptacles, which are devices. Be throwing slang up in here, Mendingo. Says, I came across some plugs that were pigtailed with 10 and 12 wire on a 30 amp circuit. Is it a problem with the pigtail being 12? Well, that's an allowance that, let's see here real quickly. Let's go to here and let's go to the code and let's look at 210 and let's go, bear with me here, Mandingo. So here's your branch circuits, your general, your branch circuits, and yada, yada, yada. Cooking, fence, more than one receptacle. Okay. Okay. So we have other, so we're not talking, obviously it wasn't anything to do with cooking and ranges, obviously. Right? I mean, obviously it had nothing to do with that, your question. So branch circuit conductors that supply loads other than those specified in 210.3, and we probably should look at 210.3 real quickly because it makes reference to it. So let's go to 210.3. Other than those listed in 210.3 here, okay, which doesn't look like any of these have anything that we're talking about. Okay, so table reference specific equipment and appliances not located in 5, 6, and 7 that amend or supplement the requirements of this article. So other than that, so let's go back to where we were, kind of what we knew what we were. Okay, branch circuit conductors supply loads other than those specified in 210.3 and other than cooking appliances as covered in 210.1983 shall have an ampacity sufficient for the load served and shall not be smaller than 14 gauge. Okay. So I would think that even in your situation, it sounds like a branch tap. That's what it sounds like. Okay, so it can't be smaller than a 14. Okay, so then we're going to go down to permissible loads real quick. All right, let me come back. Whoops. Oops. Keep moving it. Okay, sorry. Back to the question. And it says, okay. So you came across some plugs, receptacles. And the pigtail was 10 to 12 AWG, 10 and 12 wire on a 30 amp circuit. What is it? 10 through 12? I'm not sure I understand the not sure I understand you. What's the 10-12? I came across the plugs that were pigtailed with 10-12 AWG wire on a 30 amp circuit. Is it a problem with the pigtail? Oh, is the problem with the pigtail being 12? Okay. Well, the issue here is that you're using it for a receptacle, right? Okay. So if you're using it for the receptacle, one I look here is the ratings of the circuit and receptacle ratings. Probably not the question you're answering, but you said it was a 30 amp rated circuit. Receptacle is 30. The maximum load is 24. I don't think so. You know what? This is interesting you asked this question because I thought I did a lesson the other day on this for 20 amp. No, it was a 30 amp rated circuit. And here's your taps. So conductors minimum size, circuit wires, taps, 14. Fixture C240.5. So we'll go look at 240 but permissible load is probably where you've got 110.23B. Okay, so the taps can be as small as 14 taps if you meet the rules. But I really want to look at something real quick in 210.23B while we're looking at it. 210.23B. So here's it says a 30 amp branch circuit shall be permitted to supply lighting, fixed lighting units with heavy duty lamp holders and other than dwelling units or utilization equipment in the occupancy. Okay, a rating of any one cord and plug connected utilization shall not exceed 80% of the branch circuit rating. Looking for something specific. Because part of me wants to say that this is falling under the tap and I wouldn't have a problem, but I wouldn't allow the 14. It can't be smaller than 14. But I remember somewhere that I wanted to look as a reference. Let's see here. 240.5 real quick. Ampacities. Actually, I don't want to deal with cord and plug. That would not be what I would want. Taps. Tap conductors. That's fixed. And let's see here. Locations. No. Single motor. No. No. For receptacles, I know how we do it for lighting. I don't think that I would allow it for. I don't think that I would allow it to be utilized for the 12 gauge for it, unless I see something different. I don't think that I would allow it to be. I would allow that to be have to be rated for whatever the brand circuit's rated at. So, to me, it just seems like they came to the box with a 10 or whatever it was for the and then made a splice and jumped over the receptacle with a 12. Okay. I don't think that I would consider that a tap. Okay. I don't think I would consider it a tap. I would think I would expect you to be able to have the same conductor on it. I don't think that I don't think that that's a tap. I think that's just a branch circuit comes to it, and then they changed over and went over to the receptacle, and they changed. Now, with that said, it could have been maybe 10 gauge being used for voltage drop, but you said that it was 30 amps. Okay. So, now, one reason why, question. I have a question for you. If it was a 10 gauge coming, because you said 30 amps, and they changed over to 12, the problem would be is it sounds like they used a receptacle that was only rated for 20 amperes, right? So if that's the case, then that takes me back to a question I have right here. So it sounds like for lighting, we do it all the time because there's an allowance. Hold on, I'll show you. If I don't go too far. Other loads, okay, that allows me to do this. So shall not be smaller than 14. Exception, the tap conductor shall have capacity sufficient for the load served In addition, they shall have an ampacity of not less than 15 for circuits rated less than 40 amperes and not less than 20 for circuits rated 20 or 40 or 50 amperes, and only when these taps supply the following loads: individual lamp holders and luminaires, a luminaire having tap conductors 410, we talked about that, individual outlets other than receptacle outlets with taps not over 18 inches long. So I would expect it to be properly sized. Oops, sorry about that, guys. But what concerns me even more is not just that, but what concerns me more is this. You said it was a 30, obviously it was a, I'm going to assume that it's a 30 amp rated circuit because you said it was a 30 and then they tapped with the 12, right? Well, if that's the case, receptacles for a 30 amp circuit have to be rated 30 amps. You can't put a 20 amp on it. So I don't know why they would have, it doesn't make sense to me that they would have dropped, it would have gone to a 12. You know what I'm saying? Doesn't make sense. See what we got here. What other questions did you answer? Wow, this, a lot of questions came up. So Sergio says 12 is okay. Show me where it says that in the code, Sergio, for receptacle. Remember, that's not a tap rule, feeder tap. It's a branch circuit, I would assume. So let's see here. Let's see here. Okay, Mendingo, right? Jay's right on. Okay. Now, if there's a luminaire, you could do that. And we do that all the time for luminaires if you keep it short, 18 inches. Let's see here. Y'all talking to me or y'all having a little discussion? Let's see. Stop. The load to be placed on is to be variable, so logic should disallow this. Yep. What other questions we had? Yeah, let's see. Anybody else? Oh, no, it's all good. Have your conversations. I just want to make sure it clear that I don't see any allowance that would allow in this case for it to be less. And again, it sounds to me like it's a 30 amp rated circuit and they're dropping down to a 12 to a receptacle. And it doesn't make sense if it was 10 gauge and then it goes to a receptacle and you drop to 12. It wouldn't make sense if it's a 30 amp circuit. This wouldn't make any sense. Plus, you're required to protect the 10 gauges at what? 30 amp overcurrent protected device. And so if we go to the rules in 240.4, you know, down here, again, we weren't talking about fixture wire. Okay, we weren't talking about grants, we weren't talking about appliances and luminaires. We were talking receptacles, by the way. All right. So if we go to 240.4, you see right here that a 10 gauge copper is 30 amperes. And we're not talking motors or anything else. And you notice that the tap conductors are permitted to be protected against overcurrent in these applications here. None of these have anything to do with receptacle applications. So I wouldn't allow that. It's a good question though. And if it's a luminaire, I might let you do something. And you cannot use the 90 degrees. You cannot use the 90 degrees except for adjustment and corrections. Just because you have an ampacity value of 90, please don't think you can use it except for to adjust or correct, unless you have terminals that are rated 90. And very rarely do you ever have terminals that are rated 90. Now, if I go from bus to bus where there's no overcurrent protected device, bus to bus, then I might have terminals that are rated 90. Then I can use a 90-degree ampacity. But then when it connects to an overcurrent device, then I probably got to jump down because I've got terminal limitations, which would be, 75 degrees C more than likely anyway. So I can use 90 for adjustment and corrections, whether it's ambient or a number of current carrying conductors, and 31015B2A and 31015B3A. I'm fine. I can do that. But I can't just use the 90-degree ampacity arbitrarily just to use it. Be nice if you could, but you can't. So you're more often than not going to be in the 75 degrees C column, more often than not. So, no worries, my brother. That's why you're here. That's why we come, because again, I enjoy doing it. Every week somebody brings other questions, and if you get something out of it, that's great. If I don't answer it all together, or I get it wrong, I'm sure I'll correct it the next time I'm around, whatever, again, because again, I don't know everything, that's for sure. So if you have digital trip breakers, I've never heard of a digital trip breaker that mimic thermal. Are you more likely to be allowed to use the 90? Now, it's all based on the terminal ratings. So typically, guys, if it wasn't numbered, what do we know? We know to use 110.14c. If it's 100 amps or less, then it's 60-degree column. If it's if it's under 100 amps, it's over 100. You're going to use. Wait a minute, how is that worded again? Sorry about that. Having a brain fart tonight. I want to make sure I get it right. There we go. So if it is 100 amperes or less, 60-degree column. Over 100 amps, 75-degree column. You'll notice that there's no allowance here. Okay, here's 75. Here's the 60. And here's the 75. So when it comes to terminal limitations, you're not given the ability to use the 90 at ampacity value. Now, I can use insulation that's rated 90, and that's the only way that I can do adjustment and corrections from the 90-degree ampacity value. But if my terminals are rated 90 and everything in the equation's rated 90, then I'm okay with 90 as long as everything's rated 90. But most of the time, your circuit breaker terminations are only going to be rated for 75. So you're going to be stuck. Now, can you use that 90 for adjustment and corrections, JW? Absolutely. Just remember that after adjustment and corrections, I'm still going to be in the 75-degree column. And all we're doing with adjustment and corrections from the 90 is to make sure that we have a conductor that still can carry the load, okay, after those adjustment and corrections. That's all we're really doing, okay? The reason that they're 65 is, again, if they're not rated for 90, then they can't handle the heat that's generated from it. So that may or may not be true, JW, but it doesn't change the fact that you got to go by what the terminals are rated. So if you get a device, and make it simple on yourself. Don't assume because it's digital that you can use 90. If the terminals will have on it, it'll be marked. If it says 90, then you can use it as 90. Just remember sure that whatever's on the other end of that conductor also has to be 90. Remember that because you go by the weakest link. So while this might be 90, right? That piece of equipment on the other end that it's connected to might only be 75 because of terminal limitations. So if that's the case, you can't use 90 here and 75 there. You've got to use the weaker link, okay? So digital might be this might be true, but typically they're still going to be rated either 75 or 60, or usually it's 60/75. But if you get a 90, then obviously if it's marked 90, you can use it. Just remember, there's something on the other end of that conductor that you have to worry about, okay? So again, so it's a good point. It's a good point because at least it makes you stop and look at the terminals on the device and say, well, what am I dealing with? Am I dealing with 90 or 75 or 60 or whatnot. So it's just, that's why electricians get paid the big bucks, because we got to think about all those things, right? Hey, good night, Christopher. Thanks for coming. I'm glad you're working. I'm hoping everybody's starting to get back to work. This COVID thing hopefully is starting to wrap up, and everybody gets back to work and gets this economy rolling again, and everybody starts having plenty of money to feed the family and all that kind of stuff. Definitely, hopefully gets back to it. So, all right, well, unless anybody's got any additional questions, I am going to cut it out for the night. And I promise tomorrow I will do my best, guys, to get your questions answered that you email me. I will get them answered. Promise. And it's just a lot of stuff going on. Most of you probably heard my mom had a stroke and then went into the hospital, and we found out she has cancer. So it's been it's been a hectic last couple days. So trying to catch up. But at any rate, I appreciate all of you for taking the time to come to the stream. One time there, we had over 50 people in the stream, so that was pretty good. So, appreciate all of you spending your time with me. Hopefully you got something out of it. If I said anything wrong or offended you or think I disagreed with something, I apologize. Do me the solid and email me and let me know so I can fix it and teach it different or whatever. I'm one of the few educators who like to take questions actually on the fly, so I don't mind doing that. But email me at info, that's INFO, at masterthenec.com. And I'm more than happy to answer any questions that you have. I'll do my best. If you guys are there in the Fast Tracks program and you've got grading, again, I'm behind a little bit on the grading, but I will get on that probably tomorrow and get that nailed down and get it all caught up and get everything done. So, again, hopefully you got something out of it. All right, guys, I am going to end the stream. And unless there's somebody has any last minute questions, I'll give you a second to type it. If not, the Fast Tracks program author is available. It's over on our website. I'll show you where it is. So here's the internet. Okay, and you literally go and put in www. Not 4 of them, just 3. www.masterthenec.com. And you'll be here. And under courses, you highlight under courses. You just move your mouse over it, and you see all these here. And you'll see that you'll see Fast Tracks right there. Of course, you could also maneuver down and try here as well. So I could click that right there. And that'll take you here. You can watch a demo video. Again, it gives you kind of a demo. You can watch that. But here's the Fast Tracks program. Covers all these topics. There's 17 units. And again, you get access to it. And here's the 17 is probably the one that's right now. There's a wait on the 2020. You can pre-order it, but there's a wait. Right now, there's your 2017. And you click right here. Quick view. And you add it, and it's $3.15. You add it to the cart, and you check out right there. And that's how you do it. Okay. Or you could get to it by clicking under courses, clicking Fast Tracks. It'll take you right to it. Okay. Of course, we have our bundle available too for those that are interested in the bundle. This bundle is the one we're going to have. All of our 2020s are included in one price. So it's $8.99. You get all of these, and instead of 12 months, you get 24 months. And you get a coupon code for $150 off. You can actually get the whole thing for $7.49. So you get everything: Fast Tracks, grounding and bonding. There's some courses that cost that alone by itself. You get industrial, commercial, and residential. It talks code, but also gives you practical wiring advice and different things to hone those skills and looking at reviewing plans and understanding plans, and so much stuff in there depending on where you are. But that's the bundle, and it's going to be at this discount code is good until June 30th. And once that's gone, it's gone. But there you go. You get all access to all of those titles. Plus, you get access to over 1,000 more books as well from Cengage. Okay, so there's tons of others. Electricity 101 course, you can get access to it and all that type of stuff. So anyway, that's the big bundle. But most people won't need the big bundle. They just want the exam prep, and that's fine. However you want. But that's our bundle that we have available. Okay. So the 2020 edition of the textbook is going to be, again, it's based on Charles Miller's book. Okay, when that Cengage is just is the educational platform. I write books for them. Okay. Yeah, the Fast Tracks also does 2014. If you're in the 14 code and you're migrating to the 2017, you can't. All the questions are based on 14 as well in the mega exam prep. They're all based on that as well. Okay. Test book, copy of it. You can print any page you want from the actual program. Every page is printable. If you want to get a hard copy, you can email me and I'll give you a link to it on Amazon. But you don't get a hard copy during this. The whole concept here was that they're all ebooks. And they're available to read online. They're available to use on your phone. All those type of ways to do it. But no, you can get books, but I don't have any deal with them when it comes to the books. Now I did help write 3 of these books: the grounding and bonding, the commercial wiring, and residential. But I don't sell the books. So because they're included in my program. So if you have enough paper, you can print out every page of the book if you want, and if you, but most people don't. Most people just print out key things. And again, if you're using it for exam prep, probably not going to go back into the book later. You're using it to get your exam, but who knows? But they are available. The books are available, and if you email me, I can send you a link to the books as well. So anyway, I've got tons of books, but to be honest with you, I never open them. Only book I open is the National Electrical Code. To be honest with you, when I teach it and I use my courses to help you learn the code, once you get through that, the whole motivation here is to teach you, okay, is to teach you to be able to maneuver and use the NEC. And once you learn, these are all bridges to help you. So the residential, commercial, industrial teach you all the nuances of residential, commercial, industrial wiring. It covers all the things like calculations and understand. In fact, residential breaks it out in every room in the house. I mean, it literally breaks down all the requirements for every little room. And so some people need that. Okay. So again, that's what that does. See you, Arthur. Thanks for coming. And I've said I was going to go a while ago, so I'm going to leave. I appreciate all of you. Again, hopefully we got something out of it tonight, at least something. I want to thank Vince for coming. I literally contacted him like 40 minutes or whatever before, and I said, hey, do you want to join me? And he said, sure. So that's what I did with him. So hopefully you got something out. All right, folks. Appreciate you all. Take care. Good night. God bless. You've been listening to Electrician Live with your host, Paul Aber.